Anjan, Ashish, are you able to hear me?
Loud and clear.
Yes, yes.
Thank
I'm
you.
just waiting for exactly 11 to start.
Yeah.
Hello, everybody. Good
Hello,
morning.
Pramod.
Good
Hi.
morning, Dr. Chaudhary. Good morning.
Very good morning, Anjan. Where is Ashish? Ashish is there?
Yes, I'm here.
Very good.
I
Yes.
just started my slides.
You show your face once, no? That would be nice.
Can you see me?
No, I can't see you.
Oh, okay. Hold on. Let me
Try
unshare
to
for
go
a
to the
minute.
content, perhaps.
Good morning, sir. Myself, Dr. Anup Singh from DSIR. Am I audible, sir?
Yes,
Yes,
good morning.
yes, you are very much audible.
Loud and clear.
Sir, just in start, Secretary DSIR will speak for 2-3 minutes. Then, sir, a session will be hand over to Dr. Lele, and he will moderate, sir.
Okay.
Yeah.
Thank you.
sir.
Thank you.
There's an ICC seminar going on again yesterday, today. So I just gave a talk on impactful R&D.
Yeah, boy. Tanglai.
I'm sure, Anirudh, you made a big impact in the talk.
We'll know.
Morning.
Morning, Bhargavji.
Morning, sir. Good morning. How are you?
Ashish Lele here.
Yeah. Morning, sir. Mohit here.
Pandit here.
Nice connecting, sir.
Good morning. Anjan here.
Morning.
Dr. Anup, can we begin? Is Dr. Mande going to come? Anup ji?
Sir, just wait for 1 or 2 minutes, sir.
Okay.
Sir, there is some technical problem, so Secretary Sir's speech is not coming in this session. Please, you can begin the session, sir.
Okay, thank you. Thank you very much. Okay, good morning to everyone. My name is Ashish Lele, and I'm the moderator of this exciting session on green energy and low carbon technologies. We have 1 hour into this program, and we have 3 eminent speakers. There's one presenter who will speak for 20 minutes, followed by 2 experts who will speak for 10 minutes each. I will introduce them very quickly and also the rapporteur for the program today. So the first presenter is Professor A.P. Pandit. He's the Vice Chancellor of the Institute of Chemical Technology. Does not really need a introduction to this audience, but as a matter of formality, let me do a very brief introduction. Professor Pandit is a chemical engineer by training. He obtained his bachelor's degree from IIT BHU and a PhD from the ICT, which was earlier UDCT. He worked for several years in the Department of Chemical Engineering at the University of Cambridge, and his research passion has been for many years intensification of physical and chemical processes. He is a very decorated scientist. He's the Sir J.C. Bose Fellow, a recipient of many, many national and international awards, Fellow of all the Science Academies of India, and also the Fellow of the World Academy of Sciences. Has many, many publications, books, patents, and many process technologies that have been licensed to his credit. The first expert is Dr. Pramod Chaudhary, again, extremely well known. He's the CEO of Praj Matrix. He's the first generation techno entrepreneur and the founder and executive chairman of Praj Industries, which is, of course, a globally well known company in the bioindustrial sector. All of us know him as the ethanol man of India. He has spearheaded biofuels movement in India since 2007. He has been recognized very recently by two very, very distinguished awards, the 2022 William C. Homburg Award for Lifetime Achievement in Bioeconomy and the prestigious George Washington Carver Award in 2020, given by the BioImpact in the USA. He's also named as the globally top 100 people in the bioenergy industry. He's a distinguished alumnus of the IIT Bombay and also an alumnus of the Harvard Business School. Our second expert is Shri Mohit Bhargav. He is the head of Renewable Energy Division of NTPC Limited, which is a Maharatna company and of course the leader in Indian power sector. It's also ranked the 12th largest power generating company globally. Shri Bhargav is also the CEO of of course, the NTPC Renewable Energy Limited and also director on two of the JVs of NTPC. He is an electrical engineer by qualification and also undergone leadership training at the Harvard Business School and has a very long 30 years of experience in the power sector. And under his very dynamic leadership, NTPC has made very big strides in the last 18 months itself in the renewable energy sector. He's spearheading NTPC's energy transition program, also leading NTPC's green hydrogen initiative. And currently he's on the Clean Energy Ministerial Hydrogen Initiative Advisory Group coordinated by the IEA. These are only among the many, many distinctions that Shri Bhargav has. Our rapporteur for today is Dr. Anjan Ray. He is the director of the CSIR's Indian Institute of Petroleum in Dehradun. Anjan is a very close friend and colleague of mine. He has obtained his PhD in chemistry from UPenn in the USA, where he worked under the guidance of a Nobel laureate, Professor Alan McDermott, who we all know. And he then moved into chemical industry, has worked there for 25 years. And I don't think there is any function in the chemical industry that he has not handled, right from quality control to marketing and general management, corporate strategy, and many, many other such functions. His professional interests also span a very diverse set of fields, from surfactants and lubricants all the way to clean energy, biotechnology, supply chains, renewable energy, and so on. He's the recipient of many awards. Two of the bigger ones that he's won recently are the Jury Choice Award for Outstanding Green Energy Activist at the recent India Green Energy Award, and of course, many, many others. So we have a very distinguished set of speakers and panel today. So I'm looking forward to this very engaging session. Give you a very, very quick introduction to this session. So allow me to share just 3 slides here. Okay, so as I said, this is the, can you see my slides?
Still coming.
Can you see them now?
No, not yet.
in the interest of time, let me just begin anyway. I'm only going to say a few words.
Just come now.
Okay. So this is the session on green energy and low carbon technologies. And I am the moderator. I am also today the director of the National Chemical Laboratory of CSIR in the city of Pune. I also am a chemical engineer by training. The background is we all know about the facts. India today imports 3 million tons of carbon atoms to fuel its economy. All of them are today from imported fossil sources. Only a small fraction today comes from renewable energy. So in a way, we are heavily dependent on other countries because we don't have access on our own to these fossil fuel sources. And that costs us a lot of forex. About $160 billion is what we spend. It also causes us emissions of 2.6 gigatons of CO2 per year, and we are the fourth largest emitter in the world. Also, a lot of problem with air pollution, particularly the PM 2.5 pollution, which causes, of course, a lot of problems in terms of health and therefore lost labor income. In the COP26 last year, our Honorable Prime Minister made a very important statement where he said that what is needed today is mindful and deliberate. Dr. Anup Singh, can you please mute your microphone?
Anup Singh ji, mic mute kijiye, please.
Thank you. Okay, so in his announcements, he talked about Panchamrut, and I'm not going to read about them. What is important to note here is that the transition to green energy and low carbon technologies in the country has to be done, of course, but must be done so that both the energy and the products produced from it are affordable, the energy is accessible, is adequately supplied to both industry and infrastructure utilization. And also, importantly, that when we do this transition, we must be able to quantify the decarbonization targets that we have set ourselves to. This transition will have many collateral benefits in terms of jobs, revenues to farmers, rural entrepreneurs, boost to SMEs, and so on. There are, of course, multiple green energy technology options, and some of our eminent speakers are going to talk about them. Many of them, however, these technology options are today at prototype levels, and therefore the challenge that we have is to be able to take from the prototype level to very large scale and at extremely high speed, something that the whole globe and we also have not done in the past. So this is a very key challenge. And therefore, in this context, the indigenous R&D, which is particularly focused on translational R&D, is very critical. Okay, so the India's budget announced this year provides very, very large opportunities, which will help to achieve this scale and at good speed. For example, there's a PLI scheme for high efficiency solar module. There is a program on, there's a proposal for increasing the biomass firing in thermal power plants, which also reduces emissions. There's focus on energy efficiency and savings. The 4 large pilots announced for coal gasification and conversion into chemicals. And there is, of course, thrust on promotion of R&D in these sunrise sectors. And there are many policies that enable collaborations among industry, academia, and public institutions. There's also promotion of thematic funds, blended finance, 20% of which coming from government in these particularly sunrise sectors, which includes climate action. In this background, therefore, in this session, we will hear perspectives of stakeholders that are present today, particularly the speakers today who come from academia and industry. The ownership of these stakeholders will be noted down and how it will help in implementation of these budgetary provisions. If need, we will also hopefully ask for some specific provisions. For example, the National Green Hydrogen Mission, which has been around, which we know about, but has not found a place in the budget. So maybe we should be able to make some specific provisions and asks. and suggestions on how to implement these provisions, because we are part of this budget. We have ownership in implementing this budget, as the Honorable Prime Minister said in his opening remarks. So with that very brief introduction, I'm now going to request the first presenter, Professor Aniruddha Pandit, to make his presentation.
Okay, thank you, Ashish, and very nice to see you all. Let me start sharing this because very nice introduction has been given by Ashish, and I'm sure you would be in a position to understand the importance of this. The commitment given by our Honorable Prime Minister is also there in COP26. So we will have to, let me see if I can make it a slideshow, otherwise I'll not waste time in this. If we can look into the strategies which are really need to be looked at, the only inexhaustible sources of energy which are currently available to us is solar energy and its manifestations such as biomass and biomass derived fuels. And Dr. Pramod Chaudhary will talk about that a bit more. Or direct conversion of solar energy to electricity. Now, electricity is the highest form of energy which we use. I will briefly talk about why the form of energy, very similar to you using water, appropriate quality water for appropriate application. It is necessary for us to also match this. Second issue is the energy available in the form of gravitational force or gravitational energy and its manifestations such as hydroelectricity, tidal and wind energy. All these in principle can be considered as inexhaustible sources of energy. One aspect which either Professor Dr. Lele showed as well as the earlier presenters have showed, that nobody is taking into account the quantum of energy which is used in cooking. With 16% of the world population, the quantum of energy which is used in cooking is approximately, on the lowest side is 26% and the highest side is as high as 40%. So on an average, you can say 30% of the total national energy consumption goes in cooking alone. And this issue has been completely unaddressed. And even when Prime Minister's Ujjwala scheme shows a success, it is only limited to 30% of the population. 70% of the population still rely on biomass or aggregate agricultural residue. So when 5 to 7% of agricultural residues to be burned with coal in power plants, I wonder what is going to be the cost of that and how the availability will be affected. Once the highest form of energy, the electricity, which is available to us. So once that energy is available, you need to utilize that particular energy for, you can use it for any anthropological activity. But as I said, this energy needs to be looked at from an exergy point of view. That is what is the percentage conversion of that energy in terms of work, or what is the fraction of the energy available for carrying out usual work. So exergy analysis tells us essentially what is the direction in which we can sustain this particular operation. Larger the destruction of exergy, less sustainable the entire practice is. So energy is conserved, energy, nothing gets destroyed there, but exergy does get destroyed. So it is necessary for us to do exergy analysis. The same electricity, once you generate, can be used, as I said, in case of green or clean hydrogen can be used. And I know that a lot of effort is currently being done in this particular direction, including Dr. Lele and his group. And this then can be utilized for either local generation or distributed generation, which is the need of the hour, because storage and transport of hydrogen is still a bit of a concern in terms of cost as well as safety issues. But the technologies related to fuel cell are the step in the right direction, and they need to be promoted, and they need a bit more work to be fully matured and acceptable readily. We need, while we develop this, we also need to look at the entire hydrogen spectrum in terms of the type of hydrogen which can be generated. Hydrogen, which is generated using electricity, which is generated from solar energy, is the green hydrogen. Then you have a blue hydrogen, which is a natural gas being steam reformed and capture of carbon. Then gray hydrogen, then you have black and brown hydrogen. All these definitions have been given. Now, this is important because many a times the availability of the hydrocarbon source or availability of a source from which the hydrogen can be generated are limited. Now, we are still relying on fresh water for hydrogen generation. So the need of the hour is, can we use saline water, which is available in plenty for the generation of hydrogen? And there are certain technological barriers there as well. Once the issue of clean and energy gets, let's say, addressed, then we need, which is essentially taking us in the direction of net carbon zero. This generation of the energy needs to be appropriately distributed, appropriately transmitted, appropriately used for the anthropological, for carrying out anthropological activity, be it industrial, be it transportation, be it heating purposes, or be it for cooking purposes. One must understand, based on the thermodynamic analysis, every 10 to the power 6 joules of incident solar energy, by the time it is available to us in the usable form, 6 orders of magnitude reduction takes place, and only 10 joules of energy is actually available when you use it as a fuel. If you use the direct radiations, yes, all that energy is available. But when you convert it into biomass, when you convert it into a fossil fuel, which has been generated over millions of years ago, the conversion is 10 to the power 6 orders of magnitude reduction. So even when we say that the source is inexhaustible, one needs to look at in terms of this reduction in the order of magnitude of solar conversion to usable form of energy which happens. Now this, I think the concept of International Solar Alliance, which is promoted, which is led by Dr. Ajay Mathur as his director, is again a step in the right direction, where multiple, let's say, countries are coming together, sharing their experiences and trying to do and share their research and R&D efforts to maximize these conversions from solar energy to any form of energy which is directly usable. Now, once you look at this and understand the concept of green and clean energy, the next direct in line is the low carbon. Inherently, it is linked to the previous as well. When you say low carbon technology, it means you are developing technologies which are essentially using energy which is either clean or green energy. Now, when you use these energies in the form of clean or green energies, you have to consider not only the conventional concepts of material energy balance, we need to adopt the process system engineering approach. So in addition to the life cycle analysis, which takes into account essentially the resources only, where what happens to the cradle to grave approach, what resources are being utilized, and what products which you get, how much of the resources which is utilized gets converted into product. Now that is not sufficient, because all these material products are not permanently going to be available. They are exhaustible product. So one has to look at its ecological balance. So you need to look at an ecological life cycle analysis, which takes into account not only the resource balance and not only cradle to grave or limited to resource, but also the ecological impact of each of these conversion which is associated with it. So thereby, we are now then addressing essentially the concepts of circular economy or biomimicry, where the concepts of converting something and the product being a raw material for something else, and the system keeps on integrating itself. So gradually we need to move away from network of industrial systems to network of industrial ecological systems. I'll explain to you in a bit more detail in due course of time. So basically, if I just want to say, if you consider, for example, a thermal power plant where the input is fuel and water, whatever fuel it can be, and the output, if you're using conventional thermal power plant, output is SO2, CO2, warm water, some ash, and of course the electricity. So effectively, CO2 can then be sent to a cement plant to convert it to SO2 can be sent to a cement plant to convert into calcium sulfate. Then that particular cement can be combined with ash with a concrete block. So similarly, can we add few more industries where the output which is coming from the thermal power plant, which is SO2, CO2, warm water, ash, and electricity, to some other applications. So this is the original proposal when we consider a network of industrial systems. We go a bit ahead of it. So network of industrial ecological, this what cement plant which produces CO2, can I harvest that particular CO2, fix that CO2 in the forest ecosystem, which in turn generates oxygen. That oxygen is made available for running, for the carrying out the combustion purposes. Also, the forest with products in the form of a biomass can also be utilized as a fuel. The water which I am getting generated, can I treat and use that particular water to develop wetlands as well as systems, ecosystems, which again will generate either methane or algal mass like this. So essentially, moving away from a network of industrial systems, we need to move away from network of industrial ecological systems, which essentially takes us in the direction of sustainability while keeping all the needs. But as you can imagine, when you try to integrate multiple units in it, the systems becomes much more complex. So it is a multi-step optimization process which you need to carry out. If you look at the interaction between all of this system is so complex that it will take us a number of years to arrive at a combination. But at least we should start looking into certain hours in this region or certain hours in this region. This entire picture is in front of us. We can start working in the small blocks of this big picture and then keep on contributing either as an industry or as a research institute. So the challenges which we face in a network of industrial ecosystem design, industrial systems are well studied and deterministic. Ecological systems are not well understood and designed by self-organization. So integration of industrial ecosystems require a significantly better understanding, as well as we require some common treatment platform, that is mathematical treatment platform, which then can be utilized for optimization purposes. It results into a very complex network, but at the same time, we require policies from the government to promote this concept and use and adaptation of NIS as an integral approach. Very similar to whatever changes and recommendations which are made by Ministry of Environmental and Forestry and Climate Change. We are adding few things to it, not only pollution control, but environmental impact control, LCA analysis, the microbial flora, the biodiversity. All these things are going to get added up, and essentially you need to address all these issues to sustain ourselves in terms of meeting the requirement of the aspirations of Indian people, as well as keeping the growth. So greenhouse gas emission from transport and chemical sectors already account for nearly 30% and is projected to increase. There is a need for renewable alternative fuels, which cannot be overemphasized. Now, Department of Biotechnology, the Government of India has been promoting innovations and R&D in this area of advanced biofuels, addition to capacity building and needful infrastructure creation. Cellulosic ethanol, which we will hear more from Dr. Pramod Chaudhary, has been developed by 2 bioenergy centers, including a center at ICT. CSR labs are also actively involved in it, and along with the oil PSUs such as IOCL, HPCL, BPCL, everyone is contributing to this development of green energy form in the form of biomass to usable chemicals, either chemicals as well as fuels, including International Solar Alliance, which I mentioned to you earlier. We require also matrix to assess our progress. Now, this matrix essentially involves multiple actions or multiple activities, and the development of essentially information and technology and information ITEF, he has developed, ITIF has developed a network of this particular system or a matrix to assess the contribution coming from the various industries. And there is a nice report available from 2021 in the magazine which talks about what is the national government's contribution and commitment. And COP26 was essentially reiterating that particular commitment. But unfortunately, if you look at the past 5 years, 2016 to 2021, out of 34 countries of which the data is available, in 2016, India had ranked 33rd. Today, India is ranked 22nd. So we have improved only one notch, whereas people like Finland, countries like Finland, Denmark, Sweden, and United Kingdom are the pace setters. So they have got a future policies which can be integrated. And I'm sure this particular budget, again, as Dr. Lele mentioned, the green hydrogen has not been addressed. So it is necessary for us to address these. A lot of innovation needs to be put into this particular system. So the ranking, which I have already told, what it tells you, the commitment from the government in terms of R&D efforts, commitment from private party in terms of putting in capital. So the flow of early stage venture capital into clean energy startups and their ability to exit via private equity buyout, mergers and acquisitions or IPO. These are some of the things which we need to consider. So we need to have a mission mode programs and collaborative approach is required to maximize the value and use of sustainable bio-based resources through the coordination of fuels, chemicals, and materials in the first phase of low carbon technologies. The integrated biorefinery approach can help to increase the value of the output, reduce cost, improve the sustainability, and the overall conversion process, very similar to NIS concept, which I talked about, which also includes the concept of circular economy and biomimicry. The task will necessitate cross-sector collaboration, including industry, government, consumers, public-private partnership, and international cooperation, which is already I talked about. A draft mission statement for the integrated biorefinery mission proposed by India and Netherlands and other member countries under the mission innovation are available for exploitation. To conclude, the entire practice needs a holistic approach to balance growth and sustainability. Thank you. Thank you, Ashish. This is where I would like to stop.
Thank you. Thank you, Dr. Professor Pandit. Very, very interesting thoughts. I think you brought to fore some very interesting concepts that, as you said, have been neglected. The fact that a large amount of energy is actually still spent in cooking. Also introducing very important and interesting concepts such as networking industrial as well as ecological systems. And we appreciate how complex that is going to be. And it might take fairly long times to reach those kinds of optimizations. But unfortunately, we don't have much time left for doing the energy transition. So we'll have to see how to accelerate these efforts. Thank you very much, and also for your very concrete suggestions on how R&D should be coordinated. With that, I would now request Dr. Pramod Chaudhary to please share his slides and give us his thoughts on bioenergy and biofuels.
Thank you, Ashish. I think Professor Pandit has made my task a little easier because he has more or less set the stage for my subject, and I'll take it from there. We're talking about green energy and low carbon technology development strategy. And I think the bioeconomy next. Bioeconomy plays a very important role in this aspect. What we are trying to show, bioeconomy, which is including circular economy for decarbonization and carbon recycling. That is the main purpose it is serving, and it contains biomobility, a form of bioenergy for biopower, and of course the biofuel. We are depending on the feedstocks, which are basically agri-based, and that's very important aspect of for the inclusive growth. The conventional bio, I will go through the variety of biofuels and then try to sum up with what are the requirements which we are having. What Honorable Prime Minister said about science is universal, technology is local, and applications are global. I think we are following it almost to the last T. India's this COP26 position on Panchamrut is very, very critical from the point of view of the agenda which is drawn, and I will go through one by one. If you go to the net zero program, 11 SDGs out of 17 are made by bioeconomy. And some of this bioeconomy subject we strongly believe is not getting its due importance. It is really covering variety of aspects of the SDGs. And we can look what is bioeconomy. Bioeconomy I'm covering in from our point of view is two parameters, two platforms, biomobility, which is for the transportation solutions, and the bioprism, which is for the renewable chemicals and materials. And in between the things, starting with the feedstocks and product lies the technology development, which is to be supported by R&D, prototype, and commercialization. So biomobility is mainly for decarbonization, whereas the renewable chemicals are for recycle of the carbon recycling. Next. Bioeconomy is the sunrise sector, and really it is helping for both energy transition and climate action. The energy transition is coming out of the use of biomobility and for other purposes, whereas the decarbonization is helping for reduction of carbon intensity and that supporting the climate action. What is there is the sugar, starch, lignocellulose, and waste. All of them cover one or the other form of carbon, and they can be converted into value-added products. The picture shows about what are the kind of crops which are there, including the crop residues, which also play a role. We need the growth enablers in this area is the feedstock supply chain. Sustainable feedstock supply chain, there's a lot of scope for R&D activities. How do you aggregate them? What kind of machinery can be developed? And number of things can be looked at that. The farmers are a scattered community. 60% of the population is farmer dependent. And how do we bring them together? So there's a farmers, producers, organizations are possible. And there are also possibility for developing entrepreneurship. Decentralized storage depots for biomass, and ultimately feedstock categorization for different biofuels. We try to do a fingerprinting of various feedstocks for their carbohydrates, for their lignin content, and then try to make the suitable raw material suitable for the respective technology and the product. Next. The conventional biofuels, the starting point is the conventional biofuels, which is nothing but the ethanol, which is done by waste from the sugar industry and also from the damage or surplus grains. These are a typical example where the government of India embark on this. Today we have reached almost 10% of blending, and the recent reports say that in the foreign alcohol year 21-22, they have saved more than 10,000 crores of foreign exchange. This is a very laudable achievement on part of the MOPNG to set up this in action. There are some enablers which will help the growth of this further, because government has declared 20% target, and the 20% is possible with the help of certain debottlenecking, biocomposting, which is another important aspect of this industry, which is going to replace the chemical fertilizers, and there can be organic fertilizer more suitable for the Indian farming. Grain availability is there. The FCI godowns are stuffed with flooded with the grains. Only the long-term supply assurance could be important. The concept of a biosyrup, sugarcane crushing happens only for 4 months, whereas we have developed a technology to have a 1 year lasting of the syrup, and that is now available. So there's a debottlenecking there happen on the part of the product, but the policy is required that it can be traded. Uniform policy for clearance of state excise is a state subject alcohol. It is also to be eased out. That is one of the major problem which is faced by oil companies and the state excises. Carbon trading mechanism is still not in place. I think that will definitely help to reduce the carbon or achieve decarbonization. How do we capture? How do we monitor? And of course, one of the important concepts continues is the capacity building with the help of the funding. So these are the few things. The CO2 is produced, which is the biogenic CO2, and it has got its own application. So some kind of a framework is also will be useful. The most important what Dr. Pandit referred about is the advanced biofuels. Biofuels from the agri residue. If you can see that they are from in the form of ethanol and also in the form of compressed biogas. There are 3 projects based on our homegrown technologies are under construction with the OMCs, and they will establish a real concept of biorefinery. If you can see that one project and something very close to this integrated approach for the ecosystem, from lignin, lignin valorization, you can do biobitumen or lignosulfonate, ethanol is produced, CO2 is there. So variety of co-products are possible, which not only help to bring down the overall cost or improve the viability, but this is what is being envisaged as a part of the R&D program, and they are being established at 4 places in the country, 3 of which are near the Punjab-Haryana belt, where there are problem of burning of agri residue. The growth enabler is the PM Jivan Yojana to support the viability gap funding. The GST is a problem. Import of enzymes. The custom duty is pretty steep, and the enzymes are required as an integral part of this. Differential pricing than the conventional biofuels, that will definitely give a justification for a new investment to take place. And of course, there's a need for reducing the capex along the line. But once this project go on stream, I'm sure there'll be a variety of possibilities to. The best part of is that there's a CO2 footprint lowest in this area. A reduction of 85%. CI reduction of 85% is a very, very critical factor, which is helping for the this carbon climate action. In case of same material can also go for manufacture of biogas, compressed biogas, which can be blended with the CNG and also produces biomanure and liquid bio CO2. The MNRE has started with some subsidy. It is withdrawn for a reason known to them, but it needs to be established because it will. Government has declared a Satat program for 5,000 such plants, which are now in limbo because of the want of this support. And definitely the viability will definitely improve if the subsidy is reinstalled. The next gen biofuels which are in the offing is the sustainable aviation fuel. You know that the CORSIA norms and the IIT demands the use of blending of jet fuels with the sustainable aviation fuel, SAF. And that is from starting 27, every year they have to blend at least 2% to reduce overall by 50% by 2050. And there are a lot of scope for this work, which is happening in the country. And that will be definitely another area, starting with the feedstocks such as sugary, starchy, lignocellulose or oil feedstocks, which can help you to produce sustainable aviation fuel. The ecosystem is yet to be fully established, and the offtake and what kind of a business model will emerge is to be seen. Technology-wise, I think the first portion of the technology is to make up to intermediate product like ethanol or IBA, but the remaining is a regular hydrocarbon conversion, which is already established technology in the petroleum industry. So blending mandates and the policy roadmap will play a very important role, act as an enabler for this sector. Of course, like again, being the new project, new technology, viability gap funding may become necessary. One area which is not yet talked much is the marine biofuels. You know, the marine wealth is definitely getting affected by the exhaust or the release from the marine engines, and that's where again the same can be addressed with the help of agri residue and lignin as a feedstocks. We can convert that into a suitable marine fuel and can achieve the reasonable marine life is saved and biodiversity is ensured. The impact will be, of course, again for the rural economy because the feedstock is onshore, whereas this will be affecting or helping for offshore kind of thing. And blending mandates, policy roadmaps, and financial support for prototype project is still in the early stage, and we are definitely waiting the government to come with a suitable policy structures. Next, we come to the future of bioeconomy. The future of bioeconomy contains biohydrogen. We talk about green hydrogen, but this is little different than the conventional green hydrogen being talked earlier. And this is a biohydrogen from a biomass. Because our approach, and we feel for the country, the farmers have to be included in any such kind of developments, farming community, rural upgradation and all that. And that's why this biohydrogen plays an important role, that you convert the biomass to biogas and go for reformation and then go for green hydrogen. Now, this is a technology which we feel will definitely become very, very critical in time to come to balance not only the climate action, but also, as I say, inclusive for the farming community. And we feel that this is going to also have further application of in fertilizer, chemicals, steel making, and other areas. So this is an environmentally technology, and I think this will be very helpful for the country to adopt it. It's still in the R&D stage, and I'm sure that in due course of time, it will become viable. Next. The other part of future of bioeconomy is renewable chemicals and materials. This is again a little bit early stage, but bioplastic, degradable plastic is one of the important things. Single-use plastics have been banned, and those are the things, the tire material and so many things are there. This will be also done with the help of starting with plant biomass or agri residues or that kind of a thing. And you can also have a circular bioeconomy, carbon recycling to be achieved, and of course, strengthening the rural economy. So these are this thing. Potential growth enablers are again a policy roadmap. What kind of a prototype will get supported in this area? In short, the overall thing, if you look at it, that what are the imperatives or key enablers which we are asking for, which we have to put forward, partly covered in the budget, but not fully covered, that differential pricing for biofuels. It is still, just now is there partly, it needs to be further strengthened. Ecosystem for carbon trading, that mechanism will definitely help push the more and more use of bioeconomical products. Preferential pricing and distribution mechanism for CI reduction. CI reduction is getting unnoticed. In fact, that is the whole agenda of net zero, that unless you go for more and more CI reduction, it will not happen. Sustainable feedstock supply chain, which is the backbone of the whole program, and also making use of including farmers through their clusters, farmer producing organizations, or some societies. They can definitely be brought into the mainstream. That will ensure a steady supply of feedstock. In the bargain, they will also get remunerated with the proper realization of the prices. Financial.
Could you
last two, sorry.
Yeah, thank you. Thanks.
These are the last slide only. This is.
Thank you.
Absolutely last. So the point is that financial assistance for prototype, for accelerating the innovation, this is one area. Today, as a private sector, we are spending from our own pocket. I think there should be a better scheme for public-private partnership for speedy commercialization of innovative technologies. The few things are there. These new types of vehicles, flex fuel cars, they will bring again more and more innovation in that area. Supply storage mechanism for E20 and flex fuel brand. These fuels need some kind of priority lending. Things today there is a problem because the lending happens very, and initial mandates for advanced and next gen biofuels such as SAF, aviation fuel, and marine biofuels. Guidelines and specifications for mandate for renewable chemicals and materials, which is also important. So there's a huge agenda for bioeconomy, and I feel that we should recommend to the government, even if you see there's bioeconomy, what is missing from most of the talk. We talk about carbon action, but bioeconomy is not finding adequate attention to that. Thank you very much.
Thank you, Pramodji. Thank you so much. It's a wonderful summary of the whole bioeconomy picture. You also talked about the future where this will lead to, and various generations of biofuels, all the way going to aviation, marine, as well as biofuels. So very, very exciting. I think the last slide was very important. 11 enabling points that need to be kept in mind. And I'm sure this will be a great input to the government.
Thank
We have, since we started 10 minutes late, I hope that the organizers will give us those extra 10 minutes. So we have about 15 minutes left. I would request Shri Bhargavji to take over and speak for 10 minutes, followed by Dr. Anjan Ray for 5 minutes, and I will take the questions on the chat box, and we will get back to the audience who has asked questions. Over to you, Shri Mohit Bhargavji.
Thank you, Dr. Lele. Thanks a lot, and thanks a lot for having me. Thanks a lot. I hope I'm audible. Thanks a lot. It's been great to listen to Dr. Pandit and Dr. Pramod Chaudhary. And I do agree that bioeconomy and the biofuel scope and what a lot of to do. Currently, I'm a practicing manager on the other side, so too much on the biofuel side. A lot of, but incidentally, I use of bio. So let me points, and I just wanted to say, to start with, that Honorable PM had set the template for India's energy transition and setting the benchmark. And Dr. Lilly, you already talked about them, so I'm not going to detail there. What it has done is it has given us both a long-term targets. And this is important in the global context, because what we have been seeing that a good amount of these have announced it, but one as well as a short based because what we have is some like 20 euros. But also very clearly laid out what we need to do in this decade by 2030. So one of the numbers there was before, and I think in your presentation you also mentioned that we've already achieved. So, but what I mean, which is decade by 2030.
Mohitji, I think we have a bandwidth problem. We are unable to hear your full sentences. Can you hear us?
Is there any can you hear me?
We are able to hear part of your speech.
Okay, so because a lot of these
Go ahead, please.
targets. Class. Can you hear me? Remember there was
Bhargavji, can you hear us?
Yeah, I can. So, is my voice still not clear?
No, it is cracking up in between. Now it looked clear. Please go ahead.
Okay. Point I was trying to make is that the point for taking forward the transition, the energy transition for India. And it gives us both the long-term and short-term targets. How it happened was that the government had shown vision early on. How it was that the government policy framework for renewable purchase obligation, interstate transit, bundling with conventional, and all that, which led to RE capacity addition at a very rapid pace. Simultaneously, the process of and the role of intermediary procurers like NTPC and SECI ensured that the largest developers and funds from across the world joined India's RE growth story. It also led to discovery of low tariff, so much so that on X-plus base, the role of NTPC ensured that the developers across the world joined India's RE growth story. It also led to discovery of a
Bhargavji, we have lost you completely now. Can you hear us?
Okay.
Bhargavji, I would have asked you to log in again, but given the short time we have, maybe you can type your bullet points in the chat box and I can read them out if you can.
Connect from so much solar consequent requires spending for therefore numbers single recovery procure large one it's just based on the constantly depending connect from other.
Yeah, Dr. Lele, can you hear me now?
Some other device.
Dr. Lele, can you hear me now?
Who is this?
Yeah, I'm Mohit Bhargav.
Yeah, we have had great problems hearing your voice. Right now, it is much better. If you could take maybe another 3-4 minutes to summarize what you wanted to say, it would really help.
Yeah, actually, I have connected from another device, so probably there was some issue. So is that okay now? Then I can probably go ahead.
This
quickly.
is great. We can see you and hear you very well. But
Okay,
sir, we have a small amount of time left, so if you could please summarize.
Yeah. I understand. So actually, there was an issue with the bandwidth. So yeah, the point I was trying to make, and maybe we'll try to keep it short. So the Pancharmrit did lay down the guidelines, and we have made rapid strides on the RE side in terms of getting a lot of capacity going. And we are on the road to rapid transition. But what probably needs to be done that when the RE capacity we're talking about is not just which is meeting the requirement, we need RE, which is dispatchable, which means that the power should be available when it is required by the consumer and not when it can be produced, which is why probably a lot of the action will now shift to providing peak-based power or RTC power. The other is also how we are looking beyond the green power generation process only and looking at decarbonization of the industries like steel, refinery, fertilizer, even shipping and aviation. And that is where probably the role of green hydrogen comes into play. And I did hear with a lot of interest the point raised by Dr. Anirudh Pandit that the green hydrogen today, we are talking about electrolyzers using fresh water. And there's a very urgent need to actually have electrolyzers using maybe saline water or whatever water is available in the system. And in fact, we'll be happy to look at these options. Our R&D wing, I'm sure Dr. Lele and other people from this group have been connecting on various issues regarding the electrolyzers. We'll be happy to take this process forward also, because on a longer term basis, the reliability of electrolyzers without affecting the availability of water or the water issues relating to electrolyzer need to be sorted out at the earliest. So I had maybe 3 or 4 quick suggestions on what we need to do. One, of course, is the fact that in terms of manufacturing, how we can look at moving forward quickly on the energy transition journey of India. One is in terms of manufacturing, because a lot of our energy transition is actually dependent on our Atmanirbhar model also, which is very essential because we cannot be building an economy which is purely import dependent. The government has already launched the PLI scheme in the budget. They earmarked 19,500 crore rupees for solar PLI manufacturing, which is very, very good and an extremely good step in actually bringing the solar side of the manufacturing into the domestic manufacturing bucket. But we also probably need to quickly move forward on, battery manufacturing, PLI for battery manufacturing, PLI for electrolyzer manufacturing, which will probably help us going forward in ensuring that even when we're looking at large scale, deep decarbonization, we have the right set of companies and the manufacturing facilities to have the right prices. The other issue which probably will need to come forward, and I think Dr. Lele mentioned it partly, that the National Hydrogen Mission is still probably, the first phase has come out, the second phase is still to come out. And that is where it's important that it does lead to creation of demand, because India is a vast market and it can actually create huge demand. It can provide actually a huge market for the consumption of green hydrogen, green ammonia, green methanol, and so on and so forth. So this is where we probably need to, this could be done either through mandates or some other mechanism. And I'm sure government is looking at that. We have given all our inputs in that regard, how we can actually take it forward. What this will do is it will go beyond decarbonizing not only the electricity sector, the electricity supply sector, but also the various other large industries, which will actually help us achieve our target of reducing our CO2 emissions by 1 billion ton by 2030, which is a very important target for us also. The third point I wanted to make in this is that there is also a need to look at possibly the end of life management, because we are talking about large number of solar panels and wind turbines and so on and so forth, and even batteries who will have a much lesser shelf life. So it's important to have policies in place for end of life management, for example, of the solar modules, because that is an area we are still trying to lump it with computer hardware and how we can take care of that. So there needs to be a very clear case of taking this forward. Similarly, there's also need to actually have the BIS standards for all the latest technology innovation. So today we are adopting a lot of BIS standards for the solar modules, how we can take it forward for the advanced cell chemistry, and so on and so forth. One of the points I heard with interest, Dr. Pandit mentioned, was about cooking, and which is where we feel very strongly that electrification of the cooking also needs to happen very, very importantly, because right now the entire focus is on making it happen through either first it was biomass, then we're trying to replace it with LPG and CNG. So we can actually move towards electrification of cooking. That will actually help us move forward on that side. And all of that can happen if we are able to provide electricity at reasonable prices. So one of the things which is also important from a suggestion or idea point of view is that when we actually look at providing electricity, when we're actually supporting the Atmanirbhar Bharat scheme, when we're providing the manufacturers with the PLI support scheme, they need to ensure that their prices are much below the import levels, because we cannot have a situation that because of supporting the domestic industry, we suddenly have a very high level of pricing. Today, the prices of renewable power are lower than the prices of the conventional power on ex-bus basis, because the import content has been very high. So we need to reach that level of manufacturing in terms of efficiency, in terms of costing, and so on and so forth. So I'll quickly like to end with 1 or 2 points about NTPC for the benefit of people. NTPC, of course, is the largest power supplier in the country. What we have set for ourselves in the next 10 years, and obviously it'll much beyond that as well, we have today 67 gigawatts of power generating capacity. So in the next 10 years, we want to create a renewable capacity which is as large as our thermal generation capacity. So we have set for ourselves a target of 60 gigawatt by 2032. And we are looking at all kinds of options in terms of producing renewable power, providing solutions for RE-based solutions for industries, for consumers, and for institutions, and so on and so forth. We're also investing a lot of energy and focus on green hydrogen and green hydrogen-based applications. So we've started 2 pilots. One, of course, is production of green methanol. I don't need to explain to this August gathering. It's basically, it'll help decarbonizing our existing power plants, because we'll capture the carbon dioxide from the chimney, combine it with green hydrogen, and produce green methanol. We're also looking at carbon capture and utilization solutions, one of which is green methanol. The other hydrogen-based application is using hydrogen for electrification, which we are planning to, which we have already started a pilot of on our stations. This is an application which will probably work very well for locations like Ladakh. The other thing quickly I wanted to mention is that the biomass-based ecosystem, and Dr. Pramod Chaudhary dwelled in great length on that. One of the things which we have started doing is we have started using biomass-based pellets in our existing power stations. This has now been mandated, is also part of the budget. The budget also mentioned that 5 to 7% of biomass-based pellets could be fired into thermal power plants. What it does is actually again helps decarbonize our thermal power plants, because the carbon dioxide content from coal, if I'm blending even 10% biomass-based pellets, so that means we are reducing the carbon emissions from the thermal power plants. So probably I'll end here, Dr. Lele, and thanks for the opportunity, and apologies for the bandwidth issue. Thank you.
Thank you, Bhargavji. Sorry, the bandwidth was missing, but you did summarize very well. And I think some of these points on making sure we have enough storage so that RTC is possible, deep decarbonization of difficult to decarbonize industry sectors, the need for PLI schemes, not just at solar, but also batteries, electrolyzers, and so on. And most importantly, the end of life treatment of all of these materials is all very key points. I don't have the time to summarize all of them, but we have Dr. Anjan Ray here, who is going to summarize the key learnings from this webinar. Over to you, Anjan. You have really a very short time. We can see the slide, Anjan. Thank you. You're probably muted, Anjan. Anjan, can you hear us?
Sorry, can you hear me now?
Yes.
I think there was again a bit of a bandwidth issue. Not sure why that's happening. Can you see the slides now and hear me?
Yes.
So without actually reading through what's on the slide, I think we had a very exciting session from the experts and a very vast canvas of all the different things that will need to be done in the area of green energy and low carbon technologies. Working backwards from what we just heard from Mr. Bhargav, while we've made rapid strides in RE capacity, we will have to look beyond RE power generation and look at decarbonization in every key large energy consuming sector and energy consuming industry, bring in PLI at component levels. Looking on the other side of the bioeconomy aspect, not only biofuels, but everything else. Dr. Pramod Chaudhary made a very clear case for consistent policy support across the value chain, and at looking at areas like sustainable aviation, marine and heating fuels over and above conventional transport fuels like ethanol and biodiesel. The overall master context, a mindset change to network of industrial ecological systems suggested by Professor Anirudh Pandit, requires a great deal of academia-industry interaction and a great deal of modeling discipline, potentially good quality of data science as well as good quality of mathematics to be involved. This is something we have not looked at before, and I think it will be a very exciting component of the journey that we foresee in meeting the Panchamrit targets that have been laid down by our Honorable Prime Minister. And clearly a translational R&D efforts should then not only deliver affordable access of users to energy, but ensure industry has the right supply chains, the right infrastructure, the right BIS standards, and we reflect all of this with proper quantitative decarbonization and end-of-life measurement. We hope this will enable appropriate self-reliance right across different strata of society and participants in the national economy. And with that comment, I hand it back to Dr. Ashish Lele.
Thank you, Anjan. Absolutely beautifully summarized. So I think we should end the session here because the speakers in the next session are already waiting. I can see Professor Ashok Jhunjhunwala. I will note down the points in the chat box and I will pass them on to the eminent speakers and seek their replies and then respond back through the DSIR office. So with that, we will end this session. Thank you very much. Over to you, Dr. Kalai Selvi.
Thanks, Ashish. Thanks for chair.
Thank you very much.
Thank you, Dr. Lele. Thank you.
Thank you.
Could we start this session, please? Dr. Kalai Selvi, are you ready?
Yeah, I'm ready, sir. Namaskar, I'm ready.
Thank you. Mr. Vinny Mehta. Vinny Mehta.
Sir, good afternoon to you. I'm here. I'm ready, sir.
Great. And Randhir Singh, are you there? Randhir,
I see him
are
logged
you
in.
there?
I see him logged in, but I'm not sure if he's there or not.
Everybody is
Yes, sir, I am here.
Great. And of course, I can see Dr. Jhunjhunwala, Professor Jhunjhunwala.
Thank you.
Welcome to the illustrious panel that is right before me. And of course, our reporter is one of the most reputed in the field of science. Now, the topic is technology-enabled development. That is the broad theme. And of course, the focus is next-gen mobility, battery swapping, and EV policies. Now, it's technology-enabled development. I need not be emphasizing much because technology, once it takes a center focus, then it is just, it is inclusive, it is swift, it is scalable and transparent, it is cutting edge and non-partisan. That is one of the reasons why we always say that the development must be focusing on the technology. Technology must act as a vehicle of development, and then that is what the kind of society that we want to achieve could be done in a better way. Now, Honorable Prime Minister, as you heard in the morning, while he was winding up his delivery, he did mention about electric mobility. He did mention about battery, and he did say that he looks forward to this particular webinar because he wants to have some innovative suggestions that could be taken forward. So with that expectation as focus, and with one limitation that almost 15-20 minutes have been kind of the earlier session, they have barged into ours. But anyway, let's try to make good as much time as it is available to us. So with this, I would like to open it up. Initially, I'll give a kind of maybe 7 minutes, kind of 7 minutes each to all the three participants. And of course, if I might elaborate, our reporter, Dr. N. Kalai Selvi, Director, CECRI Karaikudi. So your CV is there with me, Dr. Kalai Selvi, and I see that it's so impressive that probably I don't know where to start. Maybe it might take another session just to elaborate on the achievements that you have. But yes, if I might say that she, in addition to getting some of the most prestigious global fellowships, she has the most inspiring women scientist award she has got notched, and C.V. Raman Mahila Vigyan Puraskar at 12th National Women's Science Congress at Mysore. That is absolutely phenomenal. And Dr. Selvi, welcome to you. Your contributions and the R&D activities, which ranges from electrode materials to ionic liquid crystalline electrolytes. This is a very wide platter and galaxy of projects that you have been involved into, kind of supervised, taken them forward. That is something very impressive. Absolutely. PhD from Annamalai University. So Dr. Kai Selvi, now I open it, and as per the format, I give you little less than 7 minutes, so 5 minutes. So please go ahead.
Namaskar, good afternoon. Thank you for the opportunity. I will take even less than 5 minutes because I want to listen to other experts and speakers. So I just wish to just have points in the following direction. Maybe with respect to next generation mobility, I wish to learn from the learned experts. Some points on electric vehicles, automotive driving, the development of components like batteries, sensors, controllers, and what are the infrastructure that is essentially to be established in the country in terms of charging stations, swapping stations, and service on fleet. These are the points on which I'm looking for some kind of takeaway points from today's session. That is number one. And as you know from Niti Aayog, two terminologies or two business options are now becoming very, very popular. One is MOD, that is mobility on demand. The other one is mobility as a service. So instead of paying upfront a huge money on batteries, so people may be encouraged to buy the car and on a monthly basis, they can just pay for the kind of a battery utility. So this kind of business options are also getting introduced. I look forward to listen to those kind of options also. Coming to battery swapping, we are having Professor Jhunjhunwala here. So he will throw a lot of very, very enlightening information on seamless interoperability, because the kind of discussions we had with the DST, getting Professor Jhunjhunwala actively participated and he involved himself in the interoperability related discussions. And the more important thing is Indian standards and specifications for battery dimensions, chargers and connectors are to be now realized. So this is where also I look forward takeaway points from all the speakers. And coming to the last one, EV policy, right now, all of us are very familiar with the two things. One is FAME India, the other one is PLIS. So FAME India is around a 10,000 crore budget, and the government is encouraging the manufacturers of EV and HEV. Yes, and a number of projects are also given, and we from Central Electrochemical Research Institute, we have also been given enormous funding to the tune of 100 crore to come up with the prototype lithium battery manufacturing or the fabrication facility in our Chennai center. We are at it. And coming to PLI scheme, yes, we are very much ready on board to handhold any kind of industry or Indian manufacturer in the field of lithium battery manufacturing, as well as the technology on how to make LIP cells. So here again, I just wish to listen more from the speakers on the FAME India as well as PLI scheme. To what extent policy support is required, to what extent the ecosystem should be created, to what extent end-to-end market or the local supply chain has to be really strengthened. So these are the areas in which I'm looking forward takeaway points from all the great experts on board. Thank you so very much. I look forward to listen to all of you.
Thank you, Dr. Kalai Selvi. You kind of laid down the basic points that on which the entire this webinar should. You open it up with Mr. Vinny Mehta. You will be followed by Dr. Jhunjhunwala, Professor Jhunjhunwala. Mr. Vinny Mehta, Director General ACMA, is electrical engineer from IIT BHU. He is an MBA from Delhi University, and he has been at IIFT also, Indian Institute of Foreign Trade. So he has been involved in the growth and development of automobile component industry in India. So you are kind of leading ACMA, which is one of the most premier institutions of the country, taking mobility forward. You head the Manufacturing Association for Information Technology. You had headed it, the apex body of IT hardware. So it is IT, it is vehicles, and of course, with the electrical engineering as your background. So over to you, Mr. Mehta, for say 5 minutes, if I could request it. Maybe I am shortening from 7 to 5 for the initial kind of intervention. Over to you.
So thank you very much. It's an honor and pleasure for me to be speaking at this August forum. I also recognize the presence of Dr. Kalai Selvi, Professor Jhunjhunwala, and Ranveer Singh ji. And at the outset, while this event is happening in the backdrop of the Union Budget, I must congratulate and thank the Honorable Prime Minister, as also the Honorable Finance Minister, for the focus in the budget on a lot of infrastructure development, on capital outlay, on impetus to growth, especially for the MSMEs. I say that because I come from the component manufacturing industry, and of course on skill and development. And having said that, as we all know, The budget lays the framework for the next 25 years for a digitally enabled and a sustainable development roadmap for the whole country. And in the budget, we had announcements on the fossil fuel free zones policy for battery swapping and energy as a service, and of course a lot of incentives for the startup community. And of course, we believe that India could essentially be a forerunner for green mobility solutions for the world. And before I actually talk about electric mobility, just a very short introduction on the automotive industry for people who may not be sort of familiar with us. We are world number one when it comes to two-wheeler manufacturing. We are world number one when it comes to tractor manufacturing. We are world number two when it comes to bus manufacturing. We are world number four when it comes to car manufacturing. And we are world number six when it comes to what we call as heavy truck manufacturing. So literally, we are one of the leading players in the global arena when it comes to the automotive industry. And having said that, the auto component industry can't be far behind. We take great pride that we export 30% of what we produce today. We are a $50 billion component manufacturing industry, of which literally $15 billion gets exported, and that to 60% to Europe and US, and that to some of the leading global OEMs, or the vehicle manufacturers, as we say, and also the tier one manufacturers. And the entire automotive industry contributes 7% to the Indian economy as a GDP contributor, and 37 million jobs, that's what we create. So we are essentially a very key mobilizer of the Indian economy. And now shifting gears, the entire world is transitioning towards electric mobility, and India also, we are at a point of inflection. And, very recently I came across a report in the New York Times, and it said that in each of, whether it was US, Europe or China, the rate of growth of sales of EV vehicles was much faster than that of the conventional vehicles. And interestingly, people, we are going through a pandemic, chip shortages and whatnot, and the supplies have not been able to keep up with the demand, both from a component perspective and vehicle manufacturing perspective, including for EV manufacturing. Yet the consumers deposited money and they're willing to wait for months for EV supplies to happen, and I would like to believe that India is also, pretty much emulating what the world, especially the progressive nations in the world, are doing. And our Prime Minister also made this commitment of zero carbon emissions by 2070. We heard him in the morning, and it was also alluded to the earlier presentations that were made. So when it comes to the electric mobility, I think we are very close to an inflection point when it comes to the two-wheeler and the three-wheeler industry, especially. Some people will say we've already reached the inflection point. But essentially, our efforts towards electric mobility started somewhere around 2013 when we had the National Electric Mobility Plan. Thereafter, there have been several intermittent interventions. Unfortunately, there's been no continuity in the interventions that happened until the FAME 2s came in. But again, FAME 2 did not deliver as it was. FAME 1 came in, then FAME 2 came in. FAME 2 did not deliver as it was supposed to be because ecosystems wasn't in place. Okay, I wouldn't blame the scheme per se, but now that the FAME 2 has extended, and also there are several other policy measures, deliveries that have happened. Essentially, we talked about the PLI for ACC battery, PLI for auto and auto components, and you all will be very happy. Probably you already know about it, that 20 companies have been cleared under the PLI for auto. So 20 OEMs have been cleared for making electric vehicles and also advanced automotive technologies. Similarly, 10 companies have been cleared for the battery ACC, and 90 component companies have applied for the PLI for the auto and auto components. We yet need to know how many of those 90 companies will get the incentives under the government, but it's a sheer music that 90 of the companies have the courage and the conviction that they can, transition to electric mobility. So this is something really very, very good. Also, I think what is very, very historic and notable is that our government has announced the green hydrogen policy, and we aim to be a global leader in production of 5 million tons of green hydrogen by 2030. So this is also a step towards, looking at a green environment, looking at sustainable development and manufacturing. Also, Prime Minister did allude to the fact that today there is a very, very vibrant ecosystem around the startups. He said that we are the world's largest and the most thriving and fast growing ecosystem when it comes to EV, to the startups. And also there is a lot of good contribution that's happening by the startups in the space of EVs and also in software development. And a number of centers of excellences have come up when it comes to EVs. In fact, ACMA, which is the Component Manufacturers Association that you introduced so well, we have set up 2 centers of excellence on electric mobility, one with IIT Delhi, this is in their Sonipat campus, and another one together with IIT Bombay at Powai. And I believe, with a whole lot of generous funding available from the angels and the venture capitalists today, this EVs, the startup space, dovetailed into the EV space is really going to lead the industry forward in a very, very positive direction. So also now very quickly, Crystal, grazing into the future, what could be a possible future when it comes to electric mobility? We believe, and I'm really looking from a market perspective because we are an industry association very focused on market creation. And of course, ecosystem is also very important. I'll speak about it also. But 5 years from now, what could be a possible future is that you could probably have 10% of the two-wheeler industry becoming electric. And when I say 10% may look small, but the two-wheeler market is a humongous market. We do something like 20 million two-wheelers every single year. So when you talk about a 2 million two-wheeler, it's not a small number. And for all if the total cost of ownership goes down, this number could really become very, very big. The three-wheelers is a very interesting story. Almost, we believe 30 to 50% of three-wheelers could be electric in the next 5 years. And of course, passenger vehicles, the pace is still somewhat small or slow because, typically all the incentives are focused on, if I may use the word, more bang for the buck when it comes to the government, So the offtake in the passenger vehicles is a little bit slow. So we believe about 5% of the passenger vehicles of the entire 3 million market, annual market that we have could be electric. And of course, I must congratulate the CESL and the Niti Aayog for their impetus on demand aggregation for three-wheelers and also for the buses. And I think that is something going to be really revolutionary when it comes to adoption of buses. That would really be accelerating very, very fast. Also, the offtake of smaller e-trucks would be very, very fast, essentially facilitated by the e-commerce industry and the e-commerce players and demand aggregators, including the taxi ones. So that is one possible scenario, and maybe I've been a little bit conservative, and if things work out, there could be a much better acceleration there. And probably what could some of the factors that could lead to an aggressive growth, I think first and foremost, and it's often talked about, is that of range anxiety. And I think the government and the industry needs to work together on creating a ubiquitous charging infrastructure. It's already happening, and it needs to gather more pace. And I think, we also need standardization of battery chargers. This would also reduce cost of the chargers, and also, one needs to allow for more interoperability for help mitigating the range anxiety. Of course, another issue is the high cost of electric vehicles. There could be various models. Battery swapping could be one model of reducing the cost. But again, banks are very reluctant to finance electric vehicles. It is seen as a poor asset because resale value is less. And I know Niti Aayog has been in dialogue with the Reserve Bank of India requesting EVs to be considered under the priority sector lending. So should that come through, that will not only reduce the cost of financing, but also make financing available to a larger segment of the people. And of course, Niti Aayog has also been talking to the World Bank for the first loss risk sharing instrument. So maybe in your talk, either you or Mr. Randhir can update us where we are on that front. Cost of batteries, of course, is one of the single largest costs. And I believe under the PLI scheme, where 10 companies have come in, there would be a lot of localization, not just localization. We are very breathtakingly looking forward to newer chemistries to come up, which could actually reduce the cost of the batteries. On a very similar note, both ACMA and SIAM and the other OEMs are working together when it comes to demand aggregation for auto components. So some of the items such as motors, connectors, power electronics, wire harnesses, pumps, common lightweight items, which are all in non-competitive space. If the demand could be aggregated, then this will create a sufficient scale for the component industry to invest in these, which we are actually importing from China right now. I also believe that the OEMs, new and the traditional ones who are getting into the electric mobility space, should play their role very, very responsibly, because they should not overpromise to the consumers on their delivery dates and stuff like that. And the product expectation should meet the need of the customer. And finally, green energy is going to be the absolute key to the success. We've spoken about it. And honestly, on the way forward, there has to be a lot of collaboration between the existing players and the startups and the newer ecosystem players. And of course, what will emerge is the interconnectedness of service and non-service business. And with disruption in mobility space, we have seen several service businesses emerge. In fact, I would say that the number of new service businesses in the mobility space are amongst the highest in the startup ecosystem. Going forward, the service mobility business will impact the design and build of non-service business, and therefore will impact the design and build of vehicles as well. So this convergence is going to throw up a lot new opportunities. Research in the space of cybersecurity, radars, LiDARs, simulations are some of the new areas that we need to focus upon. And of course, so we are headed to a very, very different world. But again, I just now close. I must say that I have great faith in the ingenuity, talent, ambition, passion, and the spirit of entrepreneurship of our people and the government. And I'm confident that in not too distant a future, we'll emerge not only as a vibrant EV market, but also a manufacturing hub for the world. So on that positive note, I close, sir. Thank you very much for giving me a chance to put forth my perspective.
Thank you, Mr. Mehta. Thanks for emphasizing on collaboration, interconnectedness of, service and non-service kind of businesses, and of course, supporting the startup ecosystem. Absolutely top-class points that you have raised. And yes, ACMA, if I could place on record, ACMA is always by our side whenever we are into the developing of policies and things like that. And you rightly said that when this FAME 2 was kind of meandering, it was hitting a slow path, then we re-strategized the entire system and ensured that with the realization that probably one strategy for all the vehicle segments will not do. So we we segregated the strategies, we raised the incentives for one, for another we went in for aggregation model, for the third one we went in for aggregation OPEX model, and that is the reason why it is pulling off so well. Now, Professor Jhunjhunwala, thank you. Professor Jhunjhunwala, Padma Shri Professor Ashok Jhunjhunwala, Institute Professor at IIT Madras and President IIMTM Research Park, IITM Incubation Cell. he has got, he is himself.
I think most people know me. I'm interrupting. Let's save time. We can, if you allow me, I'll just go ahead and start my presentation.
Absolutely, absolutely. You are, you can proceed forward, Dr. Jhunjhunwala. If I might just mention that you received your conferred honorary doctorate by University of Mine and Blekinge, Sweden. Over to you.
Thank you, sir. My talk is going to be design and manufacture of EV subsystems in India. I'll start by what was already done by Vinny. And first of all, our oil imports in 2021, I saw that in the first 11 months, we touched $106 billion. And of course, we have 14 of the 20 most polluted cities. No wonder Prime Minister announced that EV has to be our top priority. But we must remember, as was emphasized by Vinny, that we have 200 billion auto industries, largest employer in India. He gave the number 37 million, and I have just entered it here. It needs transition for its, including ancillaries and component manufacturing of 50 billion. They need to transition. This is extremely important that we work on the transition. Way back in 2017, I was in Delhi and I was given temporary charge of this whole EV, and we realized that we need to manufacture every subsystem in India to preserve and grow sector's GDP and employment. If we do not manufacture every subsystem in India, if we allow them to be imported and just become an assembling place, we will not win. That's not what our auto sector has done in the past, and we cannot do that. So this becomes very important. We also recognized way back in 2017, battery swapping is going to play a major role in a price-sensitive market, because certainly, as Kalai mentioned, you don't have to upfront pay for battery swapping. For some reason, it was kind of blocked, and only about a year back, it was kind of accepted, and now only the finance minister has given a push. But even then, there are some obstacles. We will talk about it. The components. I mean, even if I take a motor, I was trying to count the number of parts that a motor has. It has something like 70 parts. I'm not even talking about the parts of the controller. Controller has large number of parts. And what we did is that when we started designing here, we are able to get all these 70 parts manufactured within 10-kilometer radius of my institute. So it is possible to do it in about 10, 15 places, 20 places in the country, 10 places at least in the country. So the capabilities exist. Design and manufacturing. Design is very critical. If you don't design, if you are going to design outside, well, you are going to just assemble. Then the parts will also come from outside. So designing and development and making the parts and making the full system is very, very important. Equally important for battery. Most people don't understand that even the best batteries from Germany do not work very well here, particularly the two-wheeler and three-wheeler battery, which do not have internal cooling. None of them have been designed to 48 degrees centigrade. They are massively importing things from China, and I've tested almost every vehicle from every manufacturer, and I've seen that the batteries really behave poorly because they have not been designed in India. You have to design for 48 degrees centigrade, 50 degrees centigrade. Similarly, Indian roads are very uneven. There is a lot of bouncing. Nobody has designed that on such kind of, our autos are designed, our three-wheelers are designed, our cars are designed for that. Batteries are not designed for that kind of vibration. What happens to that, with that vibration, to the life of the battery? The vibration tests, etc., that we do in ARCI and other places do not get into the life of the battery. Similarly, the electrical design. We think the electrical design is trivial, but you know, even a 1 milliohm resistance difference between two paths, because we are talking about 100 amperes and 200 amperes, we are talking about 10 watt or even higher loss and imbalance between cells. This is the reason our batteries that we are importing are not behaving Well, we have been overemphasizing battery management. Battery management system is important for safety and getting best out of each cell. But what is very important is thermal design, mechanical design, electrical design, and that needs to be carried out in India. So it needs to be manufactured in India for the long lifetime. Of course, the battery cell is very, very important. And here the technology changes every 2 years. And if you take yesterday's technology, you're outdated, because in last 10 years, the price have gone down by a factor of 10. And it goes down every 2 years when the new chemistry comes in. And if you continue to do old chemistry, sorry, we are not going to get anywhere. We need to compete on watt hour per kg. Watt hour per kg is very, very important. Unfortunately, Indian R&D is still not giving you the best battery, not giving you 300 plus watt hour per kg. And today the manufacturing has crossed 300 watt hour per kg. Fortunately, the Niti Aayog and DHI have come with a profit-like incentives. My only concern is that yes, 10 people have applied because 5 gigawatt hour was the minimum plant size. You know, China has 135 different chemistries and different plants. Even if we get even 10, it's not good enough. We should have allowed smaller plants 1 gigawatt hour and given them the incentive. I had requested that, but anyway, the decision makers are someone else. The recycling, very, very critical, was talked about earlier, was talked in the earlier cell. We do not have the material, lithium, manganese, cobalt, nickel, none of those material we have. But you know, we have large number of batteries. We have cell phone batteries. Even the 300 million cell phone batteries are thrown out every year. We can start recovering lithium from there, cobalt from there. Now, you will say that these batteries are very small, but numbers are very large. If you do 300 million, we can easily recover material for about 3 million vehicles that we need today. And tomorrow, the vehicle batteries will have to be recycled. The batteries which are on the grid will have to recycle. Recycling is very important. Fortunately, technology is available. You want to see a working plant, come to IIT Madras Research Park and we'll show you. Battery charging and swapping. I remember 2017, we had almost standardized. Some standardization was done. Very quickly in 4 to 4 months, we could have standardized. But then we have just stalemated everything. So many meetings, even I have attended, I have run away from the place. I want to avoid getting into standardization. It becomes a very difficult process in midst of lobbying. Basically, we need only 2 things minimum. Communication standards, which by and large nobody disagrees. Connector. Connector standardization, a connector which is highly affordable and manufactured in India. That's what we need. Between one connector and another connector, there are pluses and minuses, but we really don't need to delay it so much. It has to be manufactured in India. It has to be highly affordable. There is talk about maximum size of the battery. Yes, we can put, but that's all that really matters. Nothing, because it has to fit in that place. Nothing else matters. If we just do this, and this is something that now that finance minister has also emphasized that it should be done in a couple of weeks. It should not be done prolonged over months. Only communication protocols, by and large, it's already done. Connector, it has to be made in India, highly affordable. That's it. Maximum size can be specified, nothing more than that. Unfortunately, this is what is not driven today by the technical experts. It is the industry lobbies which are divided, both in Indian and foreign. And I'm telling you, frankly speaking, I'm tired of that. I want to run away from meetings like that. I know Vinny is there, but I think component manufacturers are playing less of a role. They are not so opposed, but there are companies which do not want electric vehicle to come up, and they will sit in the committee and delay everything. Well, test labs are also not desirous. We just put, say, ARCI will do. I have a lot of respect for ARCI. ARCI and all other such things are very good for testing, but they are not the ones who should do standardization. Standardization requires a small group of technical experts. Put it out, finish it out. Same thing. Once we do that, it's for both for charging as well as swapping. So, then we need, of course, a lot of chargers. Almost every charger is being imported. We need chargers of 300 watt, 600 watt, 1 kilowatt, 1.5 kilowatt, 2 kilowatt, 3 kilowatt, 5 kilowatt, 10 kilowatt, 30, 75, 200, and I can go on and go on. We need low loss and low power factor. This requires a lot of power electronics. Again, something that we are not very good. We have not cultivated the academia in that. The ones which are there are not able to go all the way from R&D to commercialization. We need R&D to commercialization. We need very large volume and high conscious biomarket design and manufacture in India. That's all that I want to really say. I think if we decide, if somebody firm says, no, we will do it in 2 weeks, maybe in a month, it can be done. If you want to prolong it, we can prolong it as long as we want. I don't know what will happen. That's all I can say, sir. Thank you very much. I have kept to my friend.
Thank you, Professor.
I need to
Junjunwala.
unshare. I have to
Thank you
unshare.
for. Are you done, Professor Junjunwala?
Yeah, I'm done. I'm done. I'm trying to unshare.
Okay. So thanks a lot. Thanks for emphasizing on the design efforts and manufacturing as the core focus. Yes, it needs a lot of thermal, mechanical, and BMS management is needed. Power electronics, that is a core area. Minimal standardization, well taken the point. Recycling, yes, the initiatives are on way, the circular with respect to circular economy. Now I invite Mr. Randhir Singh. Randhir is at Niti Aayog. He is electrical engineer. In a part of ETD 51, he has been he has done a lot of contributions. He made to Daimler and Mantra and Bus India, a Volkswagen Group company, and he was one of the youngest in the management in Daimler and also in Mantrax and buses, where he was India's CFO. He is leading this battery swapping standards and battery swapping policy. He has a key role to play there. Over to you, Randhir, on the topic in your intervention.
Thank you, sir. Sir, I will be quick. And so Mr. Mehta already said, and I echo that India is already at the inflection point of mobility revolution that is being driven by EVs. The contours of mobility landscape are constantly evolving. In 2021, 329,000 electric vehicles were sold in India. This represents a 168% rise when compared to previous years, 122,000 units. Out of the total sales in FY21, 157,000 units were high-speed electric two-wheelers and 146,000 units sold of L3 electric two-wheelers. Also, the sales of electric four-wheelers increased from 4,600 units in 2020 to 14,200 units in 2021. Now, as battery prices are falling globally, EV capital cost would become similar to ICE vehicles, and EV operational costs are already lower than ICE vehicles. The transition from traditional ICE vehicles to EV is of course inevitable, and a robust charging infra is a key prerequisite to achieve an accelerated adoption of EVs in the nation. We need to establish an ubiquitous charging infrastructure which is tailored to the need of that is India-specific transportation fleet. EVs traditionally comes with their own batteries, which need regular charging using the power supply. Battery swapping is of course an alternative which involves exchanging discharged batteries for the charged ones. This delinks and decouples charging and battery usage and keeps the vehicle in operational mode. Battery swapping is generally used for smaller vehicles such as 2- and 3-wheelers, which have smaller batteries that are easier to swap compared to 4-wheelers and e-buses. Battery swapping offers 3 key advantages relative to the charging. It is time, space, and the cost efficient, of course, provided that each swappable battery is actively used. Further, 3 important points. One is with existing technologies, charging takes at least 3 to 4 hours, adding to inconvenience and creating range anxiety. The resulting vehicle downtime is particularly significant for freight and shared mobility vehicles, whereas battery swapping is done in minutes as the batteries are pre-charged in swapping stations. Second, charging stations require more space since vehicles need to be parked next to the chargers during the charging process. However, battery swapping stations can stack multiple batteries on top of each other, and require limited parking and the limited time, which would address the space constraints in urban areas. Further, batteries account for almost 40 to 60% of the net price of EVs. Separating batteries from EVs could therefore lower the upfront cost of EVs significantly. In fact, this is the biggest deterrent as of now, thereby driving EV adoption. Battery as a service is a common business model used by battery swapping service providers. This involves users purchasing an EV without the battery, which significantly lowers upfront cost, and paying a monthly subscription fee to service providers for swappable batteries throughout the vehicle lifetime. This also gives them the flexibility of switching the CPOs, charge point operators. While battery swapping is still at nascent stage globally, it is gaining ground, especially for the commercial and the fleet operations. Our focus in the initial phase for the policy will be to cater to the light electric vehicles where it is easy to plug and play the batteries from the vehicles to the swapping stations. In long term, of course, we see buses also plying with hybrid model, wherein the fixed battery plus the swappable battery will coexist in the same vehicle. This will help in lowering the dead weight of the buses and address the range issues too. In addition to this, for commercial two-wheeler and three-wheelers, it's a boon for two reasons. First, it reduces the downtime due to the battery issues. Second, it offers the quick top-up. We already have a proven test bed from our startups like Sun Mobility, Battery Smart, who have technologically showcased the feasibility of battery swapping for two-wheelers and three-wheelers across multiple models of the vehicles. And in fact, Sun Mobility has operated battery swapping stations for e-buses in Gujarat in partnership with Ashok Leyland for almost 500,000 kilometers of e-buses. The battery swapping policy will comprehensively encompass all tenants, including technical, regulatory, operations, financing, and institutional arrangements. The policy will form the basis for the development of specific standards, guidelines, for downstream state level implementation, standardization of the battery form factor, connectors, and communication system. This will facilitate interoperability across the battery swapping stations and vehicles. And of course, it will increase the confidence amongst the battery manufacturers, OEMs, and the CPOs, that is the charge point operators. But the most importantly, the consumers with a clear policy roadmap. The policy intends to provide level playing field to all battery service providers by creating new avenues of investment in innovative business models such as battery and energy as a service. With the policy formulation on battery swapping in coordination with the relevant government and external stakeholders, we are confident battery swapping will revolutionize the electric vehicle ecosystem and place EVs at the helm with a further push to adoption of EVs in the nation. Talking about the recent developments in the battery industry, I would end with a few numbers. First is about the battery capacity deployment. In calendar year 2021, 206.2 gigawatt hour of passenger EVs were deployed onto roads globally, which is 113% more than in 2020. And out of this entire 206.2 gigawatt hour, 31% was from the one company CATL, which is a Chinese, 22% from the South Korean company called LG Energy Solutions, and 14% is from the Panasonic, whose of course 87% of Panasonic battery went to the Tesla. And in fact, of all the 286.2 gigawatt hour, 23% of all passenger EVs were only to the Tesla. And the good part is that the average battery capacity has also increased over the years, which was 52.8 kilowatt hour. Now it is 58.4 kilowatt hour. Therefore, there are few good announcements. In Q3 2021, Form Energy, they announced iron air battery for grid scale storage. In Q4 2021, in November, Bloomberg reported the battery pack prices, they are fallen by 6% to $132 per kilowatt hour. Of course, they analyze the factories which more than 8 gigawatt hour of the capacity in production. In November 2021, there was one discussion paper floated in China that no additional production, that is new vehicle which is allowed for EV batteries with cell level energy density less than 180 watt hour per kg. Why I am pointing out these numbers specifically is that our advanced chemistry cell program targets right this and leapfrogs us in terms of the battery capacity, battery deployment, and the investments also. That's it from my side, sir.
Thank you, Randeep. Thank you. Now that we are hitting 1300 hours, that was the time when you're supposed to stop. But maybe I'm just looking at the chat box. If I could just, for the benefit of 130 participants who are here, if I could just ask a question for a kind of just a minute answer. So over to you, Dala. What industry?
Yes, I have a minute only. I have to leave in a minute, sir.
Exactly.
Sorry.
That is why I said just a minute. So what industry and academia should do at this juncture to adapt the disruptive models and support country to leapfrog to EV adoption? What could these two institutions be doing?
Sir, there are already reasonable amount of industry and academia interaction going on. But my feeling is that this today the design and development has started late, but it started. And in next year or so, you will see most motors, controllers, and even the chargers will come. Packs will suddenly come from such interaction. Already is happening. Even the vehicle design, there is a lot of such interaction going on. Only thing, it has to expand. It is going on in some places, not as many places I would have liked to, but this is only going to expand. Thank you. And permit me to go, sir. I have another meeting. I'll leave.
Point well taken, Dr. Jain. We must expand this base of collaboration and interaction. Now to Mr. Mehta. How ECMA plans to make India world leader in advanced auto components, mainly EVs? Can you give maybe some of your strategy that you're planning, maybe for a minute or so?
Sir, that's a very interesting question. If you look at the evolution of the component industry, it's largely happened by way of getting technology from outside. Okay, the entire, let's say, there are probably more than 230 joint ventures when it comes to the Japanese companies alone, and largely in the technology space, because we are a very Japan-dominated vehicle industry. And similarly, there are Korean joint ventures. Similarly, a lot of the European joint ventures are there. And I think we feel in the EV space, maybe 5 years ago, technologies were not readily available. So today, technologies are also available for you to buy off the shelf. Okay, that could be one route. But as Professor said, we are also actively promoting indigenous R&D through Academia Connect. As I said, ACMA has already 2 centers of excellence. Similarly, a lot of the NITs and private colleges, engineering colleges, are also getting into industry collaboration. And I believe that would be the basis of the foundation for an ecosystem would be the engineering. And also what happens is, sir, as the market picks on, it makes eminent sense to localize, because whenever you import, the cost of import is always, the dollar is always strengthening against the rupee. And therefore, it makes eminent practical sense to localize. So with these 2 things happening, the research happening, and as market picks up, volumes build, there is increasing case of local manufacturing. And I think with the government policies being so favorable, I would like to believe that in the entire, whatever segment of the industry that you look at, probably the incentives that the government is offering to electric mobility is probably never ever heard of compared to some of the other developed countries as well. So I think we need to harness this well. And as the market picks up, sir, there's always a business case that happens. We just need to make sure that it does not create jobs in China, it creates jobs in India, and it creates manufacturing infrastructure, manufacturing opportunities in India. Yes, sir, that's how it happens.
Thank you.
It's
Thank
still
you,
a
Mr.
scientific study, but it's happening. Yeah.
Thank you, Mr. Mehta, that ACMA is planning to set up centers of excellence, and a lot of collaboration efforts are already on way. Now, final question to Randir Singh. We are into developing a lot of standards for battery swapping. What do we do so that these standards do not deter? They do not come in the way of developing innovations, supporting innovations in terms of technology and also in the adoption.
Sir, in fact, this is very pertinent question, and Professor Junjunwala also raised this issue, and he is in fact the part of the technical jury. So we are going to touch the minimum things. That means only the outer shell of the cell, only the communication protocol, and only the connector. With only these three things, we will ensure that the innovation in terms of the battery chemistry, form factor, and other things at the cell level are not touched. Those things are left for the industry, for the disruption to happen. And these three things, why these three things are important at this juncture, that means the communication protocol, connector, and the battery pack dimensions, because we have to ensure the interoperability at both the levels, at the charging and the discharging side. When we say about the charging side, it means at the swap station. Every battery should be in a position to go into each and every swap station. It will be similar to the ATM and the ATM card, wherein you don't have different dimensions of the ATM card, different ATMs and all. Similarly, you should have the single battery and the swap station, which can go to any swap station. You can withdraw the money. You can withdraw similarly the charged battery from there. And at the discharging side, that is in the vehicle, you should be in a position to put each and every battery which is available by the charge point operators in swapping mode. That is where the flexibility to the consumers are there. That is where the market driven forces will drive the prices down, bring in more competition without hindering the innovation in terms of the technology.
Thank you.
Yeah,
Thank you,
that's it.
Randir. Thank you, Randir Singh. And I do find a few questions on the chat box, and so maybe we respond to them later on mail. Now over to you, Dr. Kalai Selvi, for kind of a wrap-up round. And of course, very, very, very interesting. You set the context. You kind of laid down that what are the hinge on which the entire thing should be moving, and that is how precisely it has moved. Over to you, Dr. Kalai Selvi.
Yeah, thank you, Sinarji. Very, very interesting and very great deep dive discussions we had within the shortest possible time. I'm really enlightened that we really got a number of very useful information from all the three expert speakers. Like the way Honorable Prime Minister mentioned this morning, science may be universal, whereas technology should be local. So this is what he emphasized, that is vocal for local. So all three experts, and including you and me, all the time we were talking about throughout these 45 minutes or 50 minutes of discussion, we were talking about how best indigenization could be brought in. So I think Professor Junjunwala made it very clear that we are exactly at it by way of strengthening the industry academia, as well as industry research organization collaborations that is going on. We have to strengthen, government also should support that one. That is number one. And ACMA is already, they are well set and they are triggered and they are with their full momentum that they are going with the target of making India as the world's leader, not only in automobile manufacturing, but also to ensure that most of our vehicles are in the form of EV, because very glorified way he has given the picture. What will be there in next 5 years? How much amount of two-wheelers? So he has given maybe 10% of two-wheelers. 30 to 50% of three-wheelers, then 5% of passenger vehicles. I think if we are able to achieve this target, I think we are definitely going to do justice to make green energy and to reduce the carbon footprint. And like the way he said that the kind of incentive that the government is really doing is far, far appreciable compared to what other countries and nations are doing for them. So actively, we are promoting indigenization so that jobs will be created for Indians in India. I think that is a great touch point that ACMA has already given us a kind of a promise. And coming to battery standards, again, the speaker, he made it very clear that they are going to have focus on 3 points. One is they're not going to see the what is inside battery chemistry, because all that we guys, like we research organizations and industry and academia, we will take care of what is the kind of cell chemistry, what is its performance, energy density. Whereas Niti Aayog on the whole, or for battery standardization, they will take care of the periphery or the battery pack size and the dimension as one part. Communication protocol is the second one, and connectors is the third one. Beautifully, he has told that these are the 3 factors on which we will come up with the finalizing or freezing of standards. And I think today we have talked about how best we can create indigenous supply chain, how we can create India-based market, not only marketing, but also market acceptance, and how best all these performances can globally match with the benchmarking performance which are already there with other countries, and how best we can create jobs within India, and how best startups could be really considered in this event, because Honorable Prime Minister today morning also he said, he made a mention that number of startups who are going to be encouraged should be the maximum. I think we have covered all the points very, very beautifully. Thank you, Sinaji. I consider this as a very, very great opportunity and honor for me to listen to the entire thing. And I'll be just summarizing all these points, and I'll be sharing it with the headquarters, that is DSIR, within the next 15 minutes. Thank you so very much. I really appreciate all the speakers, moderators, and the experts. Thank you so very much.
Thank you. Thank you. I think we could latch off now. Thank you.
Thank you. Thank you, Sinaji. Thank you so much. And thank you, Ranjit. And thank you.
Sir, we have to log in again at 2 p.m.
Okay, thank you.
Yeah, thank you, sir.
Hello, NIC. Hello. Hello, NIC.
हाँ बिल्कुल ब्रॉडकास्ट
सर यस सर बोलिए हेलो
हेलो
जी सर
शैलेंद्र ने ब्रेक हो रही है
डिस्टरबेंस आ रहा है सर थोड़ा सा
ऑडियो ब्रेक हो रहा है सर
दूसरा माइक है कोई केबल को या तो चेंज करो केबल कनेक्ट करके दोबारा डिस्कनेक्ट बीच में डिस्टरबेंस आ रहा है
अब ठीक है सर
अच्छा टिकट का
हाँ अभी ठीक है
RWL चला गया ना
डिस्टरबेंस तो नहीं है सर
कंटिन्यूस कुछ बोलो 1 2 3
1 2 3 4 5 6 7 8 9 10
परफेक्ट ओके
सर कैमरा
हाँ कैमरा भी ओके
फ्लिकरिंग कुछ है तो नहीं है सर
अभी उतनी नहीं है चलेगा
ठीक है सर म्यूट कर रहा हूँ मैं सर हेलो सर
हाँ बोलिए
सर एक फ्रेम है सर का व्यू दे देना सर
ठीक है
ठीक है
यस सर
सर का ही ना एक सेल्फी बना के दे देना
हाँ 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 सर
डन सर
ठीक है सर
माइक म्यूट कर लिए सर सर माइक म्यूट कर लिए माइक म्यूट
Namaskar, sir. Namaskar, sir.
Oh,
Hello, Preeti, we can hear you. Yes, ma'am. Hello. You can hear me? Yes, ma'am. Hello. Okay, fine. Thank you.
This meeting is no longer being recorded. This meeting is being recorded.
Over to you, Pramod.
Namaskar. Honorable Ministers, senior officials, colleagues, panelists, participants, and viewers, welcome to the concluding session of today's webinar. Honorable, as India moves towards its sanitary celebrations in 2047, the budget 2022 included several new initiatives with a focus on growth and inclusive development during the next 25 years. Today's budget webinar focuses on technology-enabled development. Plenary one started with the inaugural address by Honorable Prime Minister, where he shared his vision for a technology-enabled India in the Amrit Kal and set the goals and expectations for the groups to deliberate in the breakout sessions. While emphasizing on the sunrise sectors such as AI, geospatial, drones, semiconductors, space technology, etc., he once again stressed the need for a strong 5G ecosystem, data governance, and use of technology for empowering our citizens. The principal scientific advisor emphasized that collaborations between research, academia, and industry is necessary to improve our S&T capabilities and how S&T investments will build India's capabilities of the future in diverse areas such as climate change mitigation, energy transition, telecommunication, etc. Today's event brought together leading personalities from the industry, policymakers, and government officials to dwell on the technology-related budget announcements and identify actionable strategies to ensure ease of living of common man. As we celebrate the glorious years of India's progress, especially in the field of science and technology, we acknowledge the significant and unparalleled contribution made by several eminent scientists. These luminaries shaped the scientific interventions in India and thus began the journey to ensure India's strategic autonomy in various fields of science and technology. With the Government of India's policies on Atmanirbhar Bharat, there is major focus on a self-reliant ecosystem in science, technology, and innovation, along with transfer of science to solutions. With the learnings and success stories of the past in various R&D sectors, we need to develop capabilities to find innovative S&T solutions for the benefit of common man through seamless conversion of knowledge to application. This is possible with the appropriate linkages between academia, industrial, and civil society to ultimately scale our ambitious but doable plans by 2047. In recent years, we saw the benefit of a robust biotech research ecosystem and the pharma manufacturing ecosystem, wherein our country was able to develop, demonstrate, and deliver multiple domestic vaccines for COVID. We also developed our own 5G technology with integrated efforts. We now look forward to the outcomes of the 4 breakaway sessions, which deliberated upon the positive impact of the budget to facilitate a technology-enabled environment for delivery of R&D solutions to the citizens of the country. Breakaway session 1 on building a strong 5G ecosystem for service delivery, led by Department of Telecommunication, had a focused panel discussion on promoting Make in India of 5G products and make it affordable so that the broadband and mobile services reach the remotest corner of the country. Breakaway session 2 on science and technology towards a circular economy, led by Department of Scientific and Industrial Research, dwelled on challenges in managing e-waste and development of recycling technology and policy for recycling. Panel discussions on energy efficiency, low carbon technology development, and next generation mobility also form part of the session. Department of Science and Technology led the 3rd breakaway session on promoting R&D, human resources in emerging areas, and once again emphasized on the importance of bridging the industry-academia gap for R&D innovations. And there was a special session on need for a national geospatial policy. Breakaway session 4 on emerging technologies for sustainable development, led by Ministry of Electronics and Information Technology, led sessions on motivating startups and how India can be made a global hub for data center and cloud. Now I invite the secretaries of lead ministries of the 4 breakout sessions to summarize the outcomes of today's events. The order of the presentation will be Shri K. Rajaraman, Secretary, Department of Telecommunication on breakout session 1, Dr. Shekhar Wande, Secretary, Department of Scientific and Industrial Research on breakout session 2, Dr. S. Chandrasekhar, Secretary, Department of Science and Technology on breakout session 3. The last presentation will be made by Secretary, Ministry of Electronics and Information Technology. Subsequently, we will seek the views and guidance from the Honorable Ministers of the line ministries on the deliberations on the breakout session. Over to Secretary Rajaraman.
discussions. The first one is regarding the PLI schemes of DOT and METI. And the second topic was on the use of technology, design, etc., for the delivery of services in the rural areas. So can we share the presentation? Sir, I request the PSA's office to kindly permit us to share. Yes. Thank you, sir. Thank you. So there were two sets of panelists who were. Can I request the PSA's office to kindly permit us to share the presentation?
Available, the facility is available, sir. I'm again.
Yeah. Are you able to see my presentation?
No, sir, we can't see the presentation, but the facility is available to share.
Okay. Is it now visible? Yes. Thank you, sir. So yeah, thank you. Next. So the suggestions made by the various panelists have been summarized in 4 slides. First of all, I think the first set of suggestions have come on developing India as a manufacturing. The point that was made by some of the representatives of the industry was that the India has done very well in terms of the mobile equipment manufacturing development within the country, while there are certain subsectors such as IT hardware, wearables, etc., where I think we and telecom equipment, where I think a lot more work needs to be done. So therefore, essentially, there were some of the points that were made are listed here. The first one is leveraging the large home market to spur production within the country, which I think precisely the design is for. But they would feel that they felt that there needs to be more economies of scale by bigger production facilities. The second point made by them was that there must be a greater support under the PMI scheme. I mean, where I think there must be some incentivization for TSPs for procuring local equipment, telecom equipment. There must be exclusive access at least to about 20% of the market to enable Indian champions to emerge, and use of domestic products only in certain critical sectors. So these are some of the suggestions they have given in terms of the PMI. The other points that were made was that there must be a design-led manufacturing initiative in all the sectors. I mean, I think so. They were happy to note that the telecom department has come out with a program, but they felt that similar such facilities must be available in other production linked incentive schemes as well. Then they've also mentioned that there must be no cap on R&D investments under this program, including manpower, because there are some caps relating to manpower expenditure, etc., under the scheme. They also felt that the Indian IP-led manufacturing of key mobile phone components such as displays, cameras, etc., must be given preference, so that I think we have greater value addition within this country. The next set of suggestions related to growth of R&D within the country, and India attempting to become a global R&D hub as part of the global value chain. So the suggestions included acceleration of R&D investments for 5G products with Indian design and intellectual property, and also provision of R&D grants on at least on a 1:1 matching basis with private industry for investments made to develop Indian 5G products over the next 2 to 3 years. They also felt that technology test beds, I mean, I think they were referring to the 5G test bed which was set up. So they felt right from the beginning, we set up as an industry institution consortium, so that right from the beginning, the collaboration takes place, not after the test bed is ready. So then they also suggested that we must try to create champions on for Indian intellectual property rights in the fields of 5G and mobile phones, 5G and electronics. So in the semiconductor sector, there was a suggestion that that R&D must be promoted in fabulous design for chipsets less than 28 nanometers. And the R&D funding models should be risk funding programs, which is prevalent in some countries like Israel. Next, please.
The other set of suggestions also included setting up more 5G test beds for use case development in the country, because essentially, since the use cases are just evolving, they felt that probably sector-specific use test beds need to be developed to promote a greater emergence of use case technologies. Similarly, IIT Madras Professor Ramamurthy also mentioned that there is a need to use the locally developed components for design in India. I think he was referring to the Shakti processor, which could be embedded into domestic narrowband IoT, as well as in the radio access network distribution units, etc., which are being developed under the 5G program. So this greater collaboration between various parts of the Indian ecosystem is being referred to by him. Then there is also need to align all private and public institutional efforts across the ecosystem, because it is felt that sometimes a lot of these institutions, R&D institutions, including within the government and outside, actually overlap and try to reinvent the wheel all by themselves. So it was felt that all of the institutions must join together in a collaborative effort where we divide the pieces of work and then collaborate for producing a whole. So this kind of an effort, I think, is required going forward. This was an excellent suggestion that was received. Then an interdisciplinary lab ecosystem and certification for validation is something which is very important for actually IP development within the country. Next, please. There was also a suggestion on the connectivity components. One of them was on designing a new OFC cable embedded with power cables, because essentially they were referring to the which has reached out to every village with power energy availability through electrical cables. So there was a feeling that this strength could be further harnessed by designing a new OFC cable which can be integrated with the power cables to reach out to every village. Similarly, collaborations with DISCOMs, which have already have the right of way to all the villages, must be harnessed to actually reach out to every village to achieve what the Honorable Prime Minister had said in reaching out to all the 6 lakh villages soon. Integration of communication solutions for electric vehicles is also something which there was a suggestion. Strong backhaul and connectivity and broadband connectivity using the new highways which are being built is something which needs to be given attention. Then need for spectrum use for meeting the rural needs and urban needs was mentioned, specifically with reference to E-band and V-band. So Professor Abhay Karndikar mentioned that at least 5 carriers of E-band should be delicensed to enable such use cases in rural areas, and also to proliferate the broadband speeds in rural areas. There was also the suggestion that V-band has to be delicensed to enable low power use within in captive networks. There was also a few suggestions related to captive networks, that there is a need for policies for captive networks enabling Industry 4 to flower within this country. These are some of the major suggestions which have been received during this. We will be giving a more detailed note with other suggestions also which have been received. I am stopping here because of limitation of time. Thank you, sir.
Thank you, Mr. Rajaramam. We now go on to Dr. Shekhar Mande, Secretary, Department of Science and Scientific and Industrial Research, DG CSIR. Dr. Mande.
Thank you, Professor Vijayaraghavan. So, as was mentioned by Honorable Prime Minister in his speech today morning, he said that circular economy approach will not only reduce waste, but also enable competitive industry to grow and enhance public health. So there was a key message actually in the morning, and we were assigned on these lines 4 different themes that we discussed on. One was on e-waste. The second one was on green energy and low carbon technology. The third was on energy efficiency. And the fourth one on e-mobility and battery swapping and so on and so forth. So the discussions actually took place in this, and multiple people from both academia and industry and the government, they participated in the discussions. Next slide, please. So in the section on e-waste, essentially people highlighted what is the current status, which I have listed on the left-hand panel there. I am not going to read out all of that, but it suggests that there is a huge scope based on the existing network to further grow in this particular area. And the substantial ground has been covered already by multiple institutions such as CMET, CPET, IITs and CSIR. But the policy interventions that might be required are also actually listed on the right hand side. That is, so we need to actually some policy framework for recycling and end use within India. We need to create an ecosystem for chip manufacturing, which already government has actually started work on this. Private sector roles are to be integrated for employment generation and role of stakeholders in capacity building. And this point came again and again in all the themes that skill development actually is absolutely necessary in all of these. Actually, all the 4 areas that we are talking of, skill development, because the scale that at which we want to operate, we need many, many more people. And private industries can actually come and help us in that particular aspect. And then there was creating awareness for e-waste for recycling among both users and vendors. Next slide, please. The next session was on green energy and low carbon technologies. Once again, status is lifted on the left-hand side that currently we have very high dependence on the fossil-based fuels. And by 2030, our goals are actually to 500 gigawatt of power, which would not be fossil-based. And about 25% energy demands are for cooking, which is a neglected area for transitional R&D. So this is the kind of thing actually things that came up that we should have a biofuel policy already in place. But the policy framework that would be needed would be to develop network of industrial ecological systems, which would be essentially industry academia partnerships. The bioeconomy needs a consistent policy support where we need to actually assure via mandates and supply side security of feedstock at stable prices. And some of it also could be agri residues and so on and so forth. Renewable power is to be dispatchable and invest in energy storage at scale, which of course the government has announced number of PLI schemes on these particular areas. Then decarbonize large energy consumers such as steel, fertilizers, thermal power, and so on and so forth. And PLI at component level for renewable power infrastructure, some of it is already in place. The Honorable Prime Minister also mentioned in the morning that 14 key sectors already have been for manufacture. The PLI schemes are in place, but probably we may need a few more in circular economy area. In the next slide, we talk about energy efficiency and saving measures. Now, this also was a very fascinating session where status is that higher energy use for our aspirations actually would lead to depleted resources. But an important point there was made was if we actually make a shift towards electricity, that actually might actually save our dependence on some of the other energy intensive resources by use of electricity. And electricity, of course, we can generate from non-renewable, from renewable sources as well. The policy things that would be needed, where actually private sector's roles actually needs to be integrated for employment generation in this particular aspect. Some of the very important points that were made in the policy side were things like how do we integrate the informal sector with the formal sector? For example, in e-waste recycling, we know that the integration of formal sector, informal sector needs further enhancement. And one of the suggestions that came, I mean, I just put it on for consideration here, was can we actually not also have the informal sector consider on par with small farmers and all the policies for farmers and all those things which are there. The other one was the role of stakeholders in capacity building and awareness of energy needs to be enhanced. Then audits and performance contracts and all, they also need to be improved at a very large scale. And the development of common measures and verification, they need to be highlighted. The fourth session was on next generation mobility. Slide, please. Yeah. This was actually on mobility, e-vehicle policies and battery swapping, etc. Here actually there are a number of PLI schemes already in place in this particular domain. And the status is that charging, swapping stations and service on fleet are emerging concepts. and they need to be promoted in this particular aspect. We know that our dependence on this thing is going to be increasing in the coming time, and therefore we have to be ready for both manufacture of lithium-ion batteries and the next generation batteries, which could have different chemistries, other chemistries than this. But also the infrastructure for battery swapping and all also needs to be generated at multiple places. The policy that would be needed would be to nurture Indian industries and promote the startups for indigenous manufacturing of batteries and related components for EVs through the PLI schemes, which of course is already in place now, the PLI scheme. The minimum level of battery manufacturing needs to be at least 1 gigawatt hour to meet the 55 gigawatt hour target capacity, which is aimed by the government of India today. Then we need to actually generate industry, academia, research lab consortia, and this should be encouraged on sustainable battery chemistry and form the further policies in this particular regard. And the last point was the Indian standards need to be finalized, and this actually requires a good amount of work of our standard, which are in tune with the global best practices in what actually would be policies and all in this particular matter. And the raw material supply chain has to be strengthened to so that we are not affected eventually by disruptions in the supply chain, logistics, and so on and so forth. So to summarize, what we actually need is to establish national capacity across public and private sectors, across academia and across industry, with translational research expertise, with economically viable and globally competitive technologies, which is important. And I actually mentioned the last one in the previous slide, that we have to actually tune ourselves with the globally competitive thing, because there are too many overseas players also would be jumping the gun at some point of time. So we will actually need to have our own standards which are defined according to the global standards. The timelines are quite tight, and the global players, as I said, are waiting in the wings to come in at a very short notice. So what we need to actually is a well-coordinated set of parallel efforts with clear implementation plans and effective monitoring, where accountability would be an essential ingredient. So this is essentially what we discussed in the circular economy section, but several useful suggestions, more detailed notes are available with us. So we'll be very happy to generate a more detailed note based on this. So thank you very much.
Thank you very much. I now request Secretary Science and Technology, Dr. S. Chandrasekhar, for his introduction.
Honorable ministers and dignitaries on the call today, greetings to all of you. Today, DST has coordinated two breakaway sessions. Breakaway number 3, which was on promoting the R&D human resource in emerging areas. So revitalizing the industry academia collaboration, catering to entire innovation and technology life cycle. And the second was the transforming India through geospatial knowledge and infrastructure need for a national geospatial policy. So if we look at the first session, which was attended by the panelists, leaders from pharma, automobile industry, startups, and other sectors. And we had Dr. Satish Reddy from Reddy's, Chintan Vaishnav, Mission Director, Atal Innovation, Indranil Manna, former Director of IIT and also currently President of INAE, Shankar Venugopal from Mahindra & Mahindra, Taslim Arif Saeed, and Sandeep Verma from ACRB, and Anita Gupta from DST. So the deliberations went on for 2 hours, and the major takeaway for this, while the slides are getting uploaded, actually the major takeaways from this message has been that we need to make sure that the translational research gets the top priority, as the investments into the fundamental science have gone for the last several years, and we built a nice base. And now they wanted, all the recommendations were that how we would now put our investments into translational work. Also, one major recommendation came in the industry academia collaboration, which is not on a large scale in our country currently, is the postdoctoral culture. Many of the developed nations always have postdoctoral culture, where they're the ones who do a lot of translational work and also the designation of those postdoctoral fellows to be getting assistant professors and on a tenure basis, and also routine technical and scientific audits and continuous monitoring of all the investments made by the government into research activities. So this one strong recommendation came up. Another one was on how we could really promote the research innovation, solving societal problems. As Honorable Prime Minister today was addressing, science is universal, but the science has to be used for technology for the local use. So science for local use is something all the panelists have taken into consideration. Also, while we are talking on the policy framework and patents, there has been a strong desire that the patent box has to be strengthened in such a way that the financial gains are shared between academia and industry. Also, the one recommendation was many academic institutes don't have a professional tech transfer departments, and it was felt that a professional tech transfer department with proper freedom to transfer the technology to industry without too much of bureaucratic hurdles was one important recommendation came in this sector. When we are talking of the new education policy, it was also felt that if you can really embrace some of the best Western universities and top universities in the world, we're partnering with our state universities so that the ecosystem could be strengthened. Also, another important recommendation came from the industry friends was like research-linked incentives. Many a times, the industry spends a lot of money on the R&D, but they have been requesting the government that whether they could get some tax incentives when they invest monies into R&D activities. Another major recommendation came was the coexistence of the academic and industrial partners into same campus, whether an academic institute could go and coexist on industrial campus or vice versa. That way, I think the collaborative programs could go much better. And one major recommendation from our Mahindra colleague was whether industry academia can sit together and make a 10-year roadmap that both partners invest with equal vigor so that the endpoint is defined on the day one when the program is taken up. Another sector which required large attention in R&D was the agricultural sector. While we are very strong globally in agriculture and we export a lot of food products, but the quality and the science behind production of urea, ammonia, and other pesticides and all that should be taken into consideration, and the drone technology should be brought into aggressively for this activity. So these are some recommendations which came for the academia industry collaboration. And the other session which was done was basically on promoting R&D, my apologies, was on the transforming India through geospatial knowledge and infrastructure need. So in this sector, the strong recommendation which came was leveraging the human capital that the country already has to develop products and solutions using the geospatial data now made available through an outstanding policy which allows everyone to access this data. Also, the freedom of operating drones has been a boon for this, and many startups are coming aggressively in this sector. But one major challenge has been that the shortage of the human resource. So new programs or a new curriculum to be introduced at the undergraduate and postgraduate level in the geospatial data analysis and mapping is one strong recommendation which was felt by the industry friends. Also, standardization of the professional services provided by the surveyors, VSI professionals, through industry-led certification is something recommended by all the groups. So overall, I think if we look at the recommendations for this sector, improvement in capital availability to startups and other businesses, and then geospatial investment fund to be created exclusively for startups, geospatial industry development strategy, then sectoral development plans, need to come up with a way forward in the new sector, such as highlighting in today's discussion like insurance sector, carbon credits, blue economy, and devices for strategies on how the government can play a very important role. So also look for market beyond India is one strong recommendation which came up, because geospatial now data is available for international collaborators also. So this geospatial policy would allow international players also to explore our data. So these are the recommendations came up. I stop here. Thank you, sir.
Thank you very much. I now request Secretary, Ministry of Electronics and Information Technology for his interventions.
Thank you, sir. I am Rajendra Kumar, sir, AS in MIT. I will present the recommendation from the panel, sir. I will share my screen.
Please. .
Sir, this session was technologies for sustainable development. And we had two sessions within this slot. First was on energizing startups and deep tech with data and AI. And the second was focused on making India a global hub for data centers and cloud infrastructure. We had a star-studded panel, sir, in both the sessions. In the interest of time, I will not read out the names here. In terms of the key takeaways, sir, these are listed here. The first was that in terms of the design principles for the policies and for the initiatives, they must be focused on innovation and universal inclusion in terms of ensuring that all the startups can have access to data without any difficulty. And startups, even in rural areas, they can have access to the same set of support systems and data as the startups in the cities. The second key takeaway from this panel, sir, was on investment. There was a suggestion that we could make investments of 10,000 crore, out of which half of that could be focused on AI use cases and the remaining half on the deep tech startups. So this was suggested by the panel. In terms of the need for employment generation, skilling and reskilling are the major areas which this panel recommended, and the potential to create 5 million jobs, and then for large scale skilling. That was one key takeaway from this session, sir. Then, sir, data exchange also came out as one of the key takeaways, where the focus was on ensuring that the access to data could be uniform for all the ecosystem partners in terms of ease of finding and describing data sets, in terms of security, privacy, and payments, etc., and also in terms of transferring data. So this was another key takeaway from this panel, sir. The next one was in terms of approach for adopting AI at scale. The suggestions were that problems could be identified with the government, ministry, state governments, etc. And there has to be a structured approach for problem solving using AI. So this was a key takeaway to promote startups in AI and deep tech areas. And the 4 response vectors on which we can base our initiatives were as follows: promotion of startups, then talent creation in terms of skilling and reskilling, and then preparing the country for these futuristic technologies, and opening of data sets, because they'll at the heart of the startup focused on deep tech and AI and other emerging technologies. So this was a key takeaway from this panel. In terms of the policy support, data governance framework was the focus of this recommendation. Also, we need to promote a data sharing culture and quality data creation. That is, the data sets which are curated for ready to use by the ecosystem partners, startups, then academic institutions, and the other entities to ensure that the startups can get full support. In terms of the data exchange, API Setu is one of the key takeaways, where the focus of the panel was that we could have the data sets that are now available in the government domain, both at the central and state levels. They need to be integrated through IT bridges, through API bridges, whereby the data sharing can be uniform, seamless, and access to data can be made so much easier for the startups. So the key takeaway was that supporting startups in deep tech and AI and other areas would be critical for the achievement of the vision, the target of 5 trillion digital economy in India by 2025-26. And these were the key focus areas in the panel, sir. In the second session, sir, the focus was on making India a global hub for data centers and AI. Again, we had an outstanding panel where the discussion was very focused on the support initiatives required for making India a global hub. So in this panel, sir, the key recommendations were as follows. The first was the need for larger scale augmentation of safe, secure, and trusted data center and cloud infrastructure. At present, the capacity in India is actually not comparable to what even some of our neighboring countries have, like Singapore and even a smaller country in Europe. So this needs to be augmented at a rapid rate to a much larger level. Then procurement of data center and cloud services by government departments, both at the central and state level, they need to be really looked into and ensure that they are supporting the growth of data centers and cloud service in India. Then lack of skilled resources was another area where the panel mentioned that this requires to be urgently enhanced, and we need to focus on skilling. Right now, there is a supply constraint in the economy in terms of quality resources for IT sector and data centers and cloud infra specifically. So skilling has to be taken up at a larger scale across the entire country, sir. Then another recommendation was with regard to edge data centers, which the panel mentioned that they may be promoted in rural areas because we have now the new technology like 5G coming up, where the focus would be on edge computing, and edge data centers is the way forward in future, and it's also now coming up in a large way across the entire world. Then another recommendation was on data sovereignty, the need to host data in India within the Indian IT and data center infrastructure. And it was mentioned that the data protection bill would be a key regard to ensure that the data center ecosystem gets a very strong support and a good boost. The next key takeaway was on the policy to promote use of indigenous equipment for data centers. This is already a part of the policy that we have proposed, METI has proposed, where we have proposed to give incentives for the domestic equipment, both IT, non-IT for data centers. Then CapEx support for data center growth also was mentioned as one of the key recommendations by panel, whereby we could provide support for capital expenditure for establishing data centers in India. Then resilient and redundant fiber connectivity was a key recommendation from the panel, especially rural areas where we want to promote data centers because land is available in those areas only. And this would be a key factor in really promoting these areas as the destinations for establishing data centers in India. Dark fiber access to data center and cloud players was also one of the key takeaways, where the panel mentioned that access to dark fiber now is something that needs to be addressed urgently to allow the larger scale growth of data centers in India. And one more key recommendation was that the state governments and other government agencies, they need to ensure that the NOCs and required for setting up data centers, they need to be fast tracked. This is a key area of concern where some stakeholders, they are saying that it takes several months to get all the approvals in place before they can establish a data center. So this was another key takeaway from this session, sir. So that is also, thank you so much.
I thank all the secretaries of the line ministries in bringing out the outcomes of today's breakaway sessions. And now we look upon the honorable ministers to share their guidance based on the conversations of today's deliberations. I would first like to invite Honorable Minister of State for Electronics and Information Technology and Skill Development and Entrepreneurship, Shri Rajiv Chandrasekhar ji, to provide his views on today's deliberations.
Thank you, Minister Ashwini Vaishnav ji, Minister Dr. Jitendra Singh ji, Principal Secretary, Principal Scientific Advisor, Professor Vijay Raghavan, secretaries and other colleagues of various ministries, and ladies and gentlemen. So firstly, Professor Vijay Raghavan, thank you for organizing this webinar. I think it is an extremely useful and indeed important element of what should be a permanent post-budget conversation about all things technology and technology strategy for the country going forward. So thank you for doing this, and thank you for having us speak today. I have, with some degree of attention, listened to the four secretaries and the findings on these breakout sessions. And I can see that I think we are all through this webinar beginning to converge around some broad common themes around how we need to progress this whole tech economy and the tech space into the future, in keeping with Prime Minister Narendra Modi ji's vision. We can all accept and agree that thanks to the Honorable Prime Minister's vision, India is currently has become one of the world's preeminent nations in the use of technology, not just in the conventional areas of R&D and technology development and innovation, but most importantly in the use of technology to empower and transform citizens' lives, expand the digital economy and the economy in terms of opportunities and jobs, and of course, become a world-leading player in the future of technology, future of technologies and innovation. And if at any point in the history of India, the importance of technology was to be demonstrated and reaffirmed, it is the last 2 years where technology, innovation have helped the government and assisted the government become resilient, citizenry become resilient, and indeed the economy become resilient. And I think it has been a defining 2 years in terms of how technology has been deployed and has really helped the nation in a complete entirety. This budget is quite clear, reaffirms, re-establishes or reiterates the Prime Minister's vision and strategy around deeper embedding of technology in our economy, in the way we work as a government. And he has coined the phrase "techade," which I think aptly describes what the next 10 years ought to be for us as a nation and for all of us as stakeholders in the technology economy. I will make broadly some few points. I don't want to make a long speech. It's been a long day, I can understand. The first point I want to make is that I will postulate, or I will put forward for all your consideration, that the rate and acceleration of digitization of economies, of consumers' lives, of governments are only going to intensify. And they are going to intensify deeply, and therefore that is an issue that we need to look at both as an opportunity as a challenge. Second is that there is going to be this race for innovation and technology in terms of ownership, leadership, standards in the coming years. Because like I said, emerging from the first point that I made, that technology is going to play a much more important role in the competitiveness of nations, competitiveness of economies going forward like no other time in the history of mankind. And if you take these two broad points, I would make the following cases for your respectful consideration. All of you are very experienced in both government and in technology. Most of you are more experienced in government than I am, for sure. I will argue that I have a little bit more experience in technology than some of you, but I will make the following cases. First is, I think our roadmap to technology and innovation and R&D has to be more urgent, much more driven by urgency. Our timelines have to be less gradual and more urgent. Urgency, I say, because the next 2 years, I believe, and I've used this phrase in the past, are like the Y2K moment for the world in terms of technology and innovation and the digital economy. So urgency. The second point I would put forth for all of your consideration is that out of the various R&D projects in the government of India and our overall ecosystem, we need to make them more outcome oriented, much more sharply focused on what is the result of the R&D, what is the outcome of the R&D, whether it is IPR, whether it's product, whether it's technology. Third is, and I think this point was referred to by Secretary Rajaraman and I think even DG CSIR, that this concept of collaborative development, collaborative R&D is a concept that we need to move into reality and make it much more, demonstrate a lot more efficacy. And I mean government to government, between DOT and MeitY, between MeitY and CSR, between DST and other ministries, creating an all-of-government approach towards development and the future of technology rather than ministry-led, silo-led. And including, by the way, I believe that into this collaborative approach, we must bring in the private sector as well. Some months ago, I had an occasion to work with the principal scientific advisor on the issue of scientific clusters. I would urge him to revisit that. I think it is time for that concept to be actualized and realized and made into policy. This issue of creating science and technology clusters around our universities and industry is a good idea whose time has come. The next point I want to just mention is this issue of standards leadership. It is time that India, as a global leading country on technology and innovation, plays a much more defining role on global standards. Whether it is 3GPP, whether it is ICANN, whether it is in other areas of science, technology, biotechnology, whatever. I think India needs to play a much more defining role in the standards leadership going forward. There was some reference to skilling and talent. I completely agree with those findings by these breakout sessions. It is an area that we, again, not just as a skill ministry or a MeitY or DOT, we need to find a way for the whole of government to address this issue of how do we build skills and how do we build an ecosystem that generates and develops those skills for the young Indian that is interested in the future of technology. Again, thank you, Professor Vijayaraghavan, for having this webinar. And I unfortunately missed the morning session because I was in the airport receiving students from Ukraine. I think I did that after Professor Dr. Jitendra Singh had just finished his reception of students. But that was a very energizing experience. And again, thank you for this webinar. And I hope out of this will emerge something that is a much more coherent all of government strategy and approach towards all things technology for India and the future of India and future of the India's decade. Thank you. Jai Hind.
Thank you, sir, for reassuring and reasserting the need for embedding technology and innovative solutions for the betterment of human life. Now, I request Honorable Minister of State, Independent Charge for Science and Technology, Minister of State, Independent Charge for Earth Sciences, and Minister of State for Atomic Energy, Space, Prime Minister's Office, Personal, Public Grievances and Pensions, Dr. Jitendra Singh Ji, to guide us through the deliberations. Thank you, sir.
Thank you. Good afternoon, everybody. Honorable Minister Shri Ashwini Vaishnav Ji, Shri Rajiv Chandrasekhar Ji, sitting beside me, the PSA, Dr. Vijayaraghavan, Science and Technology Secretary, Dr. Chandrasekhar, Biotechnology Secretary, Dr. Rajesh Gokhale, CSIR DG, Dr. Shekhar Mande, Secretary Earth Sciences, Dr. Ravi Chandran, all the members of the faculty, and connected with us, the colleagues from the MeitY. It's been a good learning experience over the last nearly 5 hours. I've been trying to hop among these sessions. So I was physically here attending some of these sessions which were being hosted by Science, Technology and CSIR, and trying to connect myself with the MeitY, particularly in sessions like the one dedicated to data, the other session, geospatial, e-waste, etc. I must compliment the organizers and the scientific program planners. Very intelligently, very futuristically, the themes had been decided upon. So picking up from the first session when Prime Minister addressed us and laid emphasis repeatedly on innovation, and he said this brainstorming over the day should rather be more aiming at bringing in ease of living for the common citizen through innovation rather than being a very heavy change of thought. So when I look at innovation, I think sometimes we tend to think of innovation only the terms through tend to look at it through the prism of science and through the prism of technology, where innovation is a much wider term. And if you see minutely, when we write science, technology, innovation, we write science, technology, and innovation. We don't write scientific innovation. We don't write technology innovation or technological innovation, because in English language, even each word has a separate meaning, and even similar sounding words have a different connotation. So innovation, if it has to ultimately aim at bringing in ease of living, it has to be both at the scientific level, it has to be at the industrial level, and it has to be both also at extra scientific, extra industrial level. And then a synergism of all would be possibly the most optimum combination. And I think for that, what is also required is more of awareness amongst ourselves, and awareness among others about us, and among us about others. So we have in the last few months started a process of having joint meetings of all the science ministries and science departments sitting together, including Atomic Energy and Space, which are not actually, even though headquartered in Delhi. Similarly, today also we are trying to work on the same lines, and then also sit individually with each of the ministries. Like, for example, in Jal Shakti, the CSIR recently offered the technology of heli-borne groundwater detection, which possibly was not very much known in that ministry, but now they have taken up the project in a big way. So now we have about 38 ministries which have come forward with applications for different technological interventions or technological assistance from the scientific ministries. So, and we did this exercise way back in 2015-16 and then realized the benefits of it. That is one thing. The other, now adding to what Rajiv was saying about the budget, of course, this budget is not only hugely giving a priority to science and the scientific projects, scientific schemes which were not hitherto seen, but at the same time also giving a lot of space to the private sector. Now just look at the defense sector involving about 25% of its defense research being carved out for the private sector. So that's also a huge departure from the past, because the Prime Minister has actually broken many a taboos of the past, like unlocking of space has happened, which also, you know, is going to somewhere supplement our budget, our budget allocations. We have entered into joint ventures in atomic energy. Similarly, the drone regulations have also been revisited, given otherwise what was happening was that we were developing drones, but we were developing them surreptitiously in the premises of IIT, because IIT had the mandate of producing drones for research purpose. So there's a huge departure, and I think the milieu is much more favorable for both scientific work, scientific experimentation, scientific research. The other part is the translation part, and one of the industry members in one of the groups in the forenoon, I heard him repeatedly, and I think Dr. Chandrasekhar in his sum up was also mentioning to that, the importance of translating research for the purpose of industry. I think that would also become easy if we integrate more closely, because we don't integrate that closely or optimally enough. So we actually are not able to translate. If we are able to translate each other amongst ourselves, everything that I own gets translated to the other person. So it has to be integration both within the science ministries and science departments, then the science ministries, science departments with the other sectoral ministries, and then of course the outside extra science, that would be industry, that would be startups, that would be private sector. And the other aspect which I've been strongly feeling over the last few months is that the issue of sustainable startups. Now it's become very fashionable talking about sustainable goals, but I think someday we will also start thinking with concern about sustainable startups, because what is happening is that we give certain support to startups, whether financial or otherwise. The project goes through, but the startup is lost, the team is lost, the individuals are lost, because maybe we are not able to link that project enough with the livelihood avenues. So someday the youngster sees an advertisement of civil services in a newspaper, fills in the form, and becomes a babu. So a scientist ending up as an undersecretary. So that kind of scenario, for that, I think one of the practical solutions is that we have a number of, because one of the industry representatives were complaining this morning, I think the onus has to be on them. let the industry be a stakeholder in our startup program. Many of our bodies, whether the societies, governing bodies, even in CSIR and scientific bodies, have industry representatives as members. So it adds to their profile definitely, because they've been members for so many terms or whatever in a governing body of CSIR, etc. But for us, it ends up just receiving their good advice or wise or words of wisdom. If they invest in the actual sense, let them decide what kind of expertise they are looking for, what kind of experts or skilled hands they are looking for. We'll provide the know-how, we'll train the startup, we'll also will facilitate the project. But if they invest in the project right from the beginning, then they will not bank out that easily, and the startup would also have somewhere to go back. So that is one thing. The other part is we have started a program, and I would like it to be shared with the other ministries and the members of the fraternity as well. The mentoring. You see, you would have noticed, I was saying this to the colleagues in the education ministry also. If you do a survey at class 12 level, the maximum number of students are from the science streams. So then why do we have this complaint that we have very few scientists who actually come out with some meaningful projects? Is that because they are not there because of aptitude, or they are looking for something else? They are looking for a good score to get into a NEET exam or to get into IIT JEE exam, if not that, to become, to clear a civil service exam. So if we have some kind of a mentorship program or a cutoff, which could actually enable us, what we are doing often is that we are there to provide support, help, even funding to those who come to us. If we could have a search mechanism, and then we could mentor them right from the beginning, right from the younger ages, maybe at the class 10 age, before they get corrupted by their own parents who start sending them to all kinds of coaching centers. So that could be a long-term answer to what the complaint was repeatedly being made this morning. And as Rajiv was mentioning, the private sector publicity, I said the time is not very far when this demarcation is going to end. We are going to have project-based themes, and the private and the public sector would learn that they cannot survive without each other. And there's no option now. Integration is no longer an option. It's now an essential. It's a necessity now. And therefore, I think it's been a very good brainstorming in the sense that we actually could also understand each other's concerns, and of course the data part. That session was quite interesting, hosted by the mighty. I've been of the strong view that we need Indian data for Indian solutions. Similarly, the Indian data for the Indian regimens for the treatment of Indian diseases. That is something that we have to actually focus upon, which we are lacking somewhere. And I'm sure with the kind of geospatial and the other options now available to us, we would be able to make a headway in that as well. I once again compliment the PSA and the entire team, but I think this session happened because the budget happened. But honestly speaking, this should have happened otherwise. So I think one thought to carry home is also, why are we sitting now? Just because Prime Minister asked us to sit after the budget. But what we have discussed is beyond budget. And I think this would make our exercise wholesome if we keep sitting more frequently. In fact, in our ministries, which are science-based, we've already started this process. We also then start liking each other's faces and, get used to each other and get to work together. Thank you very much, Rajiv. Thank you. Thank you, Vaishnavi. Thank you, everybody.
Thank you, sir. Now I request Sri Ashwini Vaishnavji, Minister of Communication, Electronics and Information Technology and Railways, to enlighten us on his views on the deliberation of the day.
Thank you. My colleague ministers, Dr. Jitendra Singh Ji, Sri Rajiv Chandrasekhar Ji, Principal Scientific Advisors, Dr. Vijay Raghavan Ji, Secretaries of various departments. As Honorable Prime Minister said in the beginning, this is a listening session. This is not a speaking session, so I will not take more than 3 minutes. Maybe I'll just make 4 short points. As we all know, this budget was a path-breaking budget in the sense that the focus on capital investment and the focus on technology-led growth, these were very distinctly laid out, and clear budgetary allocations were made. And as a follow-up of that budget, we are having this discussion where lots of industry participants, lots of academia, all the stakeholders are today on the same page, same table. The four brief points I would like to make here are, while going through the presentations, these are points which I jotted down while going through the presentations of various groups. Yes, we have made very big difference in the manufacturing of, let's say, electronics items, very soon telecom products. But that's something which we need to take to a very different, totally new level, is what I could sense from the presentations. Now, the thought process is absolutely in the right direction, but what are the exact action items that needs to be taken? PLI and PMI, which are two constructs that we have used for promoting domestic manufacturing, have led good results, have given us good results. Beyond this, what else needs to be done? I'll request the industry to come up with suggestions, and maybe beyond this session beyond this webinar that we have today, we should have a continuous process where we can focus more on manufacturing, because each of these manufacturing initiatives is generating a huge number of employment. So that was the first point regarding manufacturing. The second good input which came during the presentations is about the use of spectrum. I'm very happy that our thought process about spectrum is today changing. For a very long period, spectrum was seen as a mere revenue generating resource. The last 2 years have shown the public good element of spectrum. Today, from the presentation of the second group, I'm very happy to observe that there is a broad consensus on various spectrum management items, issues, which are basically leading to a public good or to a technology improvement or a technology development. This we need to now convert into clear policy or legal statements which can be then implemented. Having intent is one thing, but actual execution is more important. That is the second action item I would take away from this entire exercise. Third is about the bigger role for private sector in R&D. I think both my colleague ministers made very good points, and Honorable Prime Minister has taken this very hugely bold decision to have defense and space silos broken and letting the private sector also come in so that they can also innovate and their energies can also be put into good use for the country. I think similar initiative, similar silo breaking needs to be done in many more sectors. We are starting something in railways very soon. Another 7 or 8 days, we would be launching that new policy where private sector R&D would become integral part, or rather a major part of railways R&D budget. We do hope that going forward, probably 90% of railways R&D budget would be in the private sector, compared to 100% in the public sector today. With that policy change we'll be making, similar policy changes we need to make in almost all the sectors, because until and unless we treat our industry, treat our academia, treat our stakeholders as startups and other stakeholders as one with us, rather than we versus them, I don't think we can grow as a country. So we need to take them along. We need to make them part of our ecosystem. The fourth and last point is design-led manufacturing, which Honorable Prime Minister mentioned in the morning. I think the very nice initiative that we have taken in the semiconductor policy is something which needs to be once we see the success of this, then probably it can be replicated in many more sectors. So these are the four brief points. First is manufacturing, second is spectrum management, third is bigger role for private sector, and fourth is design-led manufacturing, on which this webinar has given us good action items, and more work we can do on these four items. Thank you, Professor Raghavan, for organizing it very nicely. This is a really good platform, and I thank all the participants for giving your thoughts in a very candid way. Thank you so much.
Thank you, sir. Now I request Professor Vijay Raghavan, Principal Scientific Advisor, to suggest the way forward.
Thank you very much. Shri Ashwini Vaishnav ji, Shri Dr. Jitendra Singh ji, Shri Rajiv Chandrasekhar ji, thank you very much for your interventions, and thanks to all the secretaries for their summary of the breakout session. This has been a very, very valuable meeting, and my job in the next 2 minutes is to thank everyone, which I've done, but also summarize the summary as it were. We really need to have a rate of acceleration of digitization and have ownership and standards and outcome-oriented collaborative R&D in private sectors. This is a very important message which Shri Rajiv Chandrasekhar gave. The message from Dr. Jitendra Singh ji was a very important one, that Indian data and Indian solutions for the Indian market need to be developed on scale. Behind this simple statement lies a very large number of challenges which we need to overcome going forward, and they relate to the private sector, the public sector, how we interact with our ministries, integrate their demands into action, and so on. And this is something which Mantriji has already initiated, and this is a very important component which we need to take to all the other ministries also, including a major mentoring program, which is very important. Shri Ashwini Vaishnav ji, you very clearly pointed out the difference which is taking place in manufacturing, in electronics and IT. But this is something, you know, when we have very little, going to something is relatively easy, but going from something to much more is a tough challenge. And that is something which you need to take up now, scaling manufacturing for the future as we go ahead. This means pushing hard from intent to execution. Execution poses all sorts of complexities. When you bring down something, something else needs to go up, and vice versa. So this is a interconnected web, when execution therefore needs to take all of that into account. The private sector opening up, which the defense R&D has done now, is something which is very important. And your point about the railway R&D going into the private sector is fantastic. And our national laboratories should also be aggregators of demands and execution through our broader ecosystem, including the private sector. And this is something which has started happening, and we need to push in a very big way. Design is key in today's world. Computers and computer-aided design allow the connectivity of high-level design, right from a shoelace to a space telescope, to be exported. And that adds key value. And when it's connected to manufacturing, brings great income also. So these are the areas which we need to go ahead taking forward. We will continue to be in touch with this entire group over here and with others in our ecosystem. Dr. Saraswat, member Niti Aayog, is here. We do not have time, unfortunately, for interventions from him, but we will consult with him and all the other stakeholders also going ahead. Thank you very, very much. And thank you all for a great session from the morning today. Thank you. Thank you.
This meeting is no longer being recorded.